All right. Hello, everybody. My name is John Baldwin. Welcome to the 2020 Fall FreeBSD Virtual Vendor Summit. So we are doing, normally this vendor summit would be physically somewhere in the Bay Area, and we're doing it online this year. So we're trying some different things. The process is going to look a little different than it has in previous years. So bear with us as we walk through and figure it out. So I wanted to share a couple of notes with you about how we think this is going to work over Zoom. First of all, during talks, we're going to allow whoever is giving the talk to kind of be the main person you see on the screen. You'll generally see their slides, and if they're talking, a little kind of overlay in one corner or the other. When we have talks, we will have some time for question and answers. And the way that's going to work is folks who are attendees on the Zoom call can use the Q&A feature to type in a question. And then one of the folks who are hosting the summit will relay that question to the speaker, or maybe the speaker will read it and then they'll answer it verbally. But we're probably not going to try to unmute people because that might be a little too complex. So that's how we're going to try to do it this time around. You can also ask questions on IRC or Slack. So just like other developer summits or vendor summits, you can join the #dev summit channel on FNet or on FreeBSD Slack. It's bridged there as well. And we'll be watching that and trying to relay any questions that you have to the speaker. In between talks, if you look at our schedule on the wiki page, we do have some breaks listed. During those breaks, they're going to be about 10 minutes each or so. We will have a timer running so that if you have to run off and use the facilities or do whatever you need to do, you can come back, you can kind of see how long it's going to be until we're going to be back and getting started. We also have, aside from talks, we have some kind of discussion groups, which will be not quite like a working group that we've done in the past at developer summits, in particular because we're online, we're virtual. But at some kind of discussion group, we're going to have one or two people kind of chair discussion. And for those, we're going to kind of see how this goes. They're probably, the person who's kind of leading that discussion may or may not have slides. We may either ask questions using the Q&A feature if you want to type questions in, or we may also unmute attendees and allow them to kind of talk back and forth with whoever's chairing that discussion. So we're going to just see how that works. Again, we'll be checking IRC and Slack, so if you have questions and you want to participate that way, you can feel free to ask on that channel. And then I guess the last thing I have for today is I want to give a bunch of thanks to the folks who kind of helped organize this summit this time around. A lot of folks in the foundation really helped a lot and spent a lot of time planning, figuring out, testing out Zoom. We had several kind of test calls with the speakers and with each other as a group. So I really want to thank Deb Goodkin and Lauren from the foundation, Mark Johnston and Ed Mass both helped, and Ann Dickinson did a lot of work. She kind of really helped organize us all, give us focus, set agendas for our meetings and so forth. So thanks to all our folks who really helped pull this off. And I think our first talk, so we should thanks. You can use the react button. It is Zoom after all. And I guess one other thing to note on the schedule, I think we sent it out in our emails, but we also are going to try one other new thing this time around. An important part of our developer summits, our vendor summits that we have with people is not just attending talks or having discussion groups, but having a chance to interact with each other and with developers. So we're going to try something new this time to try to have some of that element, because it's hard to have that kind of same, we all can't sit around a table and eat pizza like we would in the Hacking Lounge. So I think on the last day, on Friday, after the last session is over, we're going to switch off of our kind of Zoom webinar and go to a different Zoom meeting and try to do some breakout groups just to kind of get us in small groups of folks where we can sit and talk for a few minutes with each other and then kind of shuffle it a few times and have a chance just to be social. So we're going to see how that goes and try this for this year. Okay, I think that's all that I had as far as helping us get started. And our first talk for today is that, well, before we jump into our first talk, I'm going to kick it over to Deb Goodkin from the foundation, who is going to give us a bit of a foundation update. So here comes Deb.
Okay, hopefully everyone can hear me. And thank you, John, so much for that great introduction. Let me go ahead and share my screen. And, okay, great. Hopefully everyone can see this. John covered a lot of things that I was actually going to say, which is awesome. I also want to welcome everyone to this first ever virtual vendor summit. We typically do this in the Bay Area, like John said, and so this has actually allowed us to invite more people to attend this and just give a opportunity for more people within the community to connect with each other, since we really haven't had many opportunities to do that. So, so I want to thank John. What I would also like to thank the team, because they've really stepped up on making sure that this event is going to be engaging and interesting as well as fun. We do have that social event at the end. It will be interesting to see how that goes. But I do want to thank the team. I want to thank Ann Dickinson for organizing and overseeing this whole process, Ed Mass, John Baldwin, Lauren Garkowski, Mark Johnson, Gordon Tetlow, and myself. And we have a meeting like every other week to make sure that this goes smoothly. The tech is new for a lot of us. A lot of us have been using this over the past 8-10 months since the pandemic. So I'm going to give you a quick introduction to the foundation and what we've been doing to support the project this year. And I'll try to make this quick and so that we could start on time with our first speaker. So we were founded 20 years ago. We just celebrated our 20th anniversary, which is pretty exciting. We are a public charity, so we're not a trade association like other foundations, and we're here to serve the public good. We're based in Boulder, Colorado, and that's where I'm coming from. And we're 100% funded by donations. Just so you understand our relationship to the project, I put together this simplified org chart, and it just shows that we're a separate organization than the project. So we are a legal entity where the project is a volunteer community. And our purpose is to support the project. And so we will step in to fill critical needs of the project. And so it just depends on where those needs are, as well as doing other work to promote FreeBSD, as well as to help improve the operating system. We're governed by a board of 10 members who are individuals who reside all around the world, and many of them are also hands-on within the project. And then our staff, we have 6 staff members as well as 5 interns, and who are also considered staff, as well as 3 part-time contractors. So we are able to step into a lot of different areas and help the project. But also note that we're also small for purpose. So these are the 6 areas that we mainly support, and I'm going to cover the first 2 in this list. This is a list of the software development projects that we worked on over the year, and either we worked internally on these or funded outside contractors to work on these. And if we were in person, then I would have Ed Mass cover some of these, but you can find out more information in the quarterly reports. The second area that we put a lot of effort and resources into is advocating for FreeBSD. And so we started off the year by attending, I believe it was like 3 or 4 conferences in person all over the world. And with the pandemic, we had to move virtually. And it really forced us to look at our content and how we can make more available to people around the world. So we have been able to give many FreeBSD talks I'm sorry, I was just interrupted by a question, and I will address that. I'm trying to keep my eye on the time here too, but thank you. But we've been able to advocate for FreeBSD at virtual conferences around the world. So it seems like we've been able to touch and reach more people in locations that we wouldn't normally go to. For example, we were just in Argentina. And we introduced a new series too called the FreeBSD Fridays introductory series. And And I think we just hosted our 11th one, and it's every other Friday. And we focus on different areas of FreeBSD, and it's really to introduce people to those areas. And that's been very successful, and all of those talks have been recorded. We're putting on this vendor summit, and we're also looking at possibly putting on a developer summit next spring, since BSD CAN will not be held. And we brought a technical writer on staff, and that person has been able to provide more content about what we're doing as well as what the project's been doing. And so that's been great having him on staff. We updated our website, and so this allows people to find information a little more easy, as well as so how can we help them, or how they can get help, as well as companies who want to partner with us. And finally here, we started putting together some case studies on commercial users and how they're successfully using FreeBSD. And so this is the example of the Netflix one that we just published. And since this is the vendor summit, and we do have a lot of vendors here, we would love to write more. And so if you're interested in having us highlight your company and writing up a case study, then please reach out to any one of us, and we would love to work with you. We're working on planning for the next 2 years. And so the 2 areas that we're really looking at increasing support for is the software development, and we're hoping to fund some larger projects as well as more projects, even though we have funded a lot of projects this year. And we're also going to increase the education and training offering. So that includes professional training as well as college level operating system course content. We'll have more information once we have the plans put in place, probably early next quarter, and we'll be able to publicize that. And then finally, this is how we've raised money. Well, not how, but this is the graph of how much money and how much we've spent over the past 20 years. And so right now, our goal is to raise $1.25 million. We've raised $628,000. And so we're looking for especially corporate sponsors to help us reach that goal. And our budget this year is $1.6 million. Next year, it will go up to $2 million. And finally, we want to thank you for attending this and supporting us. And if you do want us to continue our efforts, then we would love to see you help by contributing to our efforts. And there was one question here on how board members are chosen by the foundation. And actually, we look at what our needs are. The board is a governing board. And so they're actually governing we are actually a corporation. And so they're helping us be accountable. They're helping with putting together the budget, putting policies together for the corporation. And so we look at people either in different regions of the world, which can help us reach into those areas, as well as they may bring expertise in maybe from other open source projects, as well as business or financial or fundraising background. So we do reach out to people and bring them on board that way. Hopefully that answered your question, and that's all I have. So I want to thank you very much and enjoy the summit. Now I just have to find the controls here.
Okay.
Sorry, I don't know how to, I'm trying to find, so I unshare my, okay, I got it.
Okay, you got it. All right,
okay,
cool.
Yes.
All right, thank you, Deb, for that note from the foundation. Our first talk today, let me check the schedule, is Heiko from Beckhoff. Heiko, are you ready to go?
Yes, I am.
Okay, let me switch the video over to you. When you're ready. Okay, you should be live, Heiko. If you want to share your screen and get started.
Yes.
Cool.
So hopefully everybody can see my screen.
Yes, looks good.
Perfect. Okay, yeah, then Thank you very much, first of all, for the invitation to join the Vendor Summit and to present our company here. So today I'm going to tell you a little bit about the company Beckhoff and how we got started with FreeBSD. So my name is Heiko Wilke. I'm product manager at Beckhoff for the embedded PCs, which I will show you in a couple of slides. Okay, first of all, I plan to show you a video which shows Beckhoff in 45 seconds. Unfortunately, that didn't work when we tested it last week. So Zoom crashed. So I don't want to happen that again. So I just put you the link here and you can have a look at YouTube for that. So I explain it to you in a short slides. So Beckhoff, in fact, is doing industrial automation. And industrial automation means we are building industrial controllers, industrial motors, so that you can automate a machine. If you're thinking about machine, there are, of course, a lot of discrete manufacturing machines, which you can see here in different areas. But it is not only related to discrete manufacturing. It can also be in other in other areas, for example, process industry. It can be building automation. Wind turbine is, for example, also a very big part of our business. We are roughly equipping more than 50% of the wind turbines in China with Beckhoff controllers. We are in the semiconductor industry, so there are really multiple industries. So we have no dedicated target industry for our devices and applications. So Beckhoff itself is a family-owned company founded 1980 in the middle of Germany. We could say in the middle of nowhere. So Förl is a small town in Germany with 26,000 people living there. The company developed quite well. So in the meantime, we are roughly 4,400 people worldwide. 1/3 roughly engineers. So we are I would say technical driven company, so strong technical background. We claim that we are a $1 billion company since last year. So these are the values you see are the euro values. So euro is usually a little bit less. So in dollars, it's a roughly $1 billion company. Now this year is of course a little bit difficult, but it seems that we can still keep at least the numbers from last year. To give you an idea where we are located, more or less all over the world, we have our own Beckhoff offices. We are usually having a direct sales approach, so that we have really our application engineers on site. They can directly help customers. We have also now in Colorado an office next to the FreeBSD Foundation, or next. I think it's a couple of kilometers away, but it's quite close. And so this is the idea, because our idea, or the idea of our owner, is that we need to understand the problem, the technical problems from the customers, so that we can find solutions for them with our technology. Okay, what does it mean? What are we selling? So we are selling a toolbox for automation. And this toolbox consists out of multiple parts. One part is the IPC part. This is also the part where I'm coming from. So I'm responsible for these smaller controllers, which you see on the bottom line. Maybe you can, here you see that. And we are producing these PCs in Germany. We have our own motherboard development in Germany. We also have our own BIOS development group, which is of course based on AMI BIOSes, but in fact we can adapt the BIOS for our needs. We also have our own assembly in Germany. So we have completely producing the PCs in Germany next to our headquarters. So everything is coming directly from us, and this makes it possible for us to really be able to, we have everything under control of the device, including really the motherboard itself and the BIOS. Then we have the IOs. The IOs are of course necessary. If the PC is the heart of the machine or the brain of the machine, the IOs are usually the arms and legs, the actors, or the sensors and actors. So they are collecting the inputs, or of course are setting the outputs, for example, contactors or whatever. These are available also in all different flavors. So these are very small IP20 terminals. We have this in IP67, and all that electronic is also, of course, developed by us and yeah, also produced in Germany. We are supporting many different field buses. You see here all these different logos. So all these field buses are supported because we want to have an open system so which can connect to more or less anything. And then on the hardware side, the third part is of course motion part. You also need motion in your machine. So we also offer servo drives. You see here, these are servo drives for servo motors, which we also produce. So we also have an own motor factory, which is not directly at the headquarters. It's roughly 200 kilometers south of our headquarters in the southern part of Germany. But this is our motor factory there. And on the right side, you see some very nice things, which are very special motion applications, which you would see in the video. This is a linear transport system, which is quite unique. And then we have something which is called X-planar. It's we call it internally the flying carpet because you have flying movers which are hovering over tiles. Very unique. And also only possible because we have the full control over all these parts here. And with our field bus EtherCAT, which I will also show you later, we have also the speed to deliver these I/O information as fast as possible. And on top of everything, we have our software, which I'm talking today a little bit about. And this is which at the end handles everything on the PC. So which is doing the real time, which is doing the PLC, which is doing the motion control and so on. So these icons just represent multiple parts and functionalities of our software tool suite. Okay, Beckhoff milestones. I will not explain you all these different milestones. So this is our standard slide. Just go to the next one, and I just picked some of these milestones. So we started in 1980, as I mentioned. Our boss started this company. Like every company, it started in a garage, or like every good startup, it started in a garage. And we started with microcontroller-based machine controllers. And in 1986, our boss invented the PC-based control system. At this time, all the PLCs were just microcontroller-based. And in this year, a customer of us asked him to connect the floppy drive to his machine controller, to the microcontroller. And then they started to develop it, and they connected it, the PC, a standard PC at this time, I don't know what it was, 286 or 386, something like that, to the microcontroller machine controller, microcontroller-based machine controller. And someone, they said, hey, that's stupid what we are doing, because we are just talking with a very powerful PC, which we just use as a floppy drive via a serial interface to this very small 16-bit controller. Doesn't make any sense. We can do the same thing on top of the PC besides everything else. And this was the birth of PC-based control as we know it today. So Beckhoff really started that, and already 2 years later, they had a standard system called S1000 based on DOS at this time, which already handled the PLC and motion control. And then the next major step was 1996, sorry, with the invention of TwinCAT, which was then the first time when this software, so this soft PLC, you could say, worked and run on Windows. And this is also where this twin came from. So in the first time we showed it was called WinCAT, but there was an issue with the name with another company, so we had to rename it, and then it was called TwinCAT, so the Windows Computer Automation Technology. Okay, so this was the birth of TwinCAT as we know it today. And then 5 years later, we started smaller embedded PCs, which were based on Windows CE. And so this was the introduction of the second operating system at Beckhoff, so the big Windows NT line, and then Windows CE as well. I just take 2004 here as the birth of EtherCAT. I just mentioned that here because this is usually very well known EtherCAT in the world, and sometimes it's more known than Beckhoff. So a lot of people which we are talking to, they know EtherCAT, but they don't know Beckhoff, and they think, okay, EtherCAT, we know that, of course, but you invented it. Yeah, we have to explain that sometimes, and then we say, yeah, we invented that in this time. Yeah, so it's a very successful over the year as a standard Ethernet-based field bus, which still is the fastest Ethernet-based field bus. Then in 2010, our new TwinCAT software came out, TwinCAT 3, which was then based on multi-core, which can use multi-cores and is also 64-bit based. And now in 2020, this is what we are talking about today, is our next operating system in our range, which is of course some kind of a replacement for existing Windows CE, which we call TwinCAT BSD. Okay, just to give you an idea what we think or how we think about PC, industrial PC with a machine controller. So we take a standard PC. Of course, it's not everything standard, but let's say it's more or less standard architecture, x86 architecture, Intel CPU. And then we put our software on it. And then we have one part of the software is doing the PLC, which can have multiple tasks in real time. One part is doing the motion control, which doing point-to-point, CNC, whatever. We have then also some other functions here. Now we also have some functions for vision as well and for machine learning. So there are all these things running in the real time. And then we have this I/O mapping here. And this mapping maps these inputs and outputs to the right field bus. In our case, we prefer, of course, EtherCAT. EtherCAT is then going to all these I/O slaves or servo drives. And the idea here is that these slaves or these I/Os are, let's say, stupid. Stupid means there is no pre-processing within these devices. So they just set outputs or just gather inputs. That's their purpose and nothing else. So the approach is here always to do everything which needs to be calculated and which needs to be processed, has to be processed in the PC, because the PC always gives us enough capabilities, always enough performance to do everything we need in the software as a software component here. Yeah, so this is the approach since 1986, and which worked quite well. Okay, what does real-time mean for us? So we have something which we call XFC, Extreme Fast Control Technology. In fact, it's a marketing word around the standard capabilities of EtherCAT. So EtherCAT has a very fast, can very fast collect inputs and send outputs. And together with TwinCAT and with our real-time, we can realize I/O response time below 100 microseconds. That means you have an input here, an electrical input, 24 volt or whatever. This input comes, then you, of course, you have some internal electrical conversion until it's get into the slave controller. Then it gets processed or it gets transferred via EtherCAT to the PC. On the PC, the PLC task is running, doing its calculation. When it's ended, it's sending the outputs as over EtherCAT again. Then this telegram is received in the output terminal, and then it's processed, and somewhere then there is a 24 volt output signal. And this everything is done below 100 microsecond. And this helps customers to really improve their control loops, reduce waste, for example, and optimize the output of the machine. Okay, so what is TwinCAT? TwinCAT, in fact, is our software tool suite, which makes the PC real-time capable. So there are lots of different TwinCAT functionalities, I would say. So all these modules you see here are parts of TwinCAT, which you can use, but you can also just use one of these parts. The base system is always the system which provides the real time. And on the real time, you can run PLC tasks, you can run your own C++ modules, you can run twin also so the safety functions. You can run vision applications, you can do motion and so on. On top, HMI, of course, is not based or is not directly in the real time. HMI is then a product which is running in user mode. And on top of that, if we are talking about real time in our world, this means usually that we are talking about milliseconds at least, or even microseconds. And our system has a cyclical approach. That means we are defining a certain cycle time. For example, 1 millisecond. And that means each millisecond, the PLC or whatever task gets called and has to execute and has to do its operation. And when it's finished, it's, yeah, you can say sleeps again and waits for the next cycle tick. That is the approach. And it's not in a free run state that it always, if it's ended, it starts again. So it's really always the same cycle time, and it doesn't just start earlier or anything. We can reach cycle times down to 12.5 microseconds. That's possible. And we already showed that, but that's getting really complicated in kind of parameterization and everything. So usually in the real world application, you will see cycle times with down to 50 microseconds. This is something which you can more or less easily handle. Okay, then TwinCAT consists more or less out of two parts. So one part is the engineering part, which is in Visual Studio integrated. And there you configure your system. You can program all your logic in C++, C, or IEC 61131, so PLC language. You can also use MATLAB Simulink. And this is, of course, yeah, done on Windows and will also stay on Windows. So this is a Windows application, but if we're talking about the second part, which is the runtime part, this is what we have now ported to FreeBSD. And so we can now use our real time on a FreeBSD system. It's not exactly FreeBSD, it's some slightly modifications there, but more or less it's FreeBSD, and we call that then TwinCAT BSD. And this is the part which then executes all these different modules which you can use there. So all the runtime products will be available then for that TwinCAT BSD. Okay, here you see the architecture. These are the two parts, engineering part and the runtime part. The runtime part, as I mentioned, is now ported to this FreeBSD. We have our own transport layer, which is called ADS, and this is usually transferred over Ethernet. So that means usually you have the programming on your laptop on Windows with this Visual Studio environment, TwinCAT XAE, and then you have your target system, for example, this embedded PC with your IOs, and you connect them with via network, and then you can directly scan the system here, get all the IO information, and then you can parameterize it. You can do all the settings, and then you can somewhere download your application here, and then you run it here on the runtime system on the target. As I mentioned before, TwinCAT supports multi-cores, and there are different ways how we can make use of multi-cores and how we can use our real-time at all. So we have two different kinds of operating modes for real-time. The first operating mode is the known operating mode, which was already invented with Windows NT in 1996. And this means that the shared core, how we call that, the shared core runs or can run up to 80% or can take up to 80% of the CPU time. That means, for example, 1 millisecond cycle time. Each millisecond, our real time gets called. We are doing our stuff. And for example, after 500 microseconds, we are finished. We are giving back the rest to the OS. You can do that up to 80%. So that means 800 microseconds. If your task or if your PLC execution takes longer, you need to cancel that. Otherwise, if you take more than 80%, you usually get weird behavior of the OS. So over time now with multi-cores, so this was necessary at the time because we only had one core and we had to share that core. Now we have multi-core system and we can do it differently. So here on a multi-core system, we can now set isolated cores. Isolated cores are available after a reboot. So if you have quad-core system, your system boots with 4 cores, and then you say, I want to have 2 isolated cores. You can do that in the settings of the TwinCAT system, and then you have to reboot once. And after reboot, the operating system only sees or has 2 cores. So you just say it to, or you just set the operating system, please only initialize 2 cores, and the other 2 cores are left. And then TwinCAT takes over these cores, initializes them, and then starts the runtime there. And there we are 100%. We can work on these cores without interfering here any processes on these cores. So this is really a good benefit, or a big benefit now for the new TwinCAT 3 system. And you can still, of course, communicate over ADS, this protocol, over between all these different runtimes and tasks, and also from the user mode here on your standard operating system core, we have an ADS lib you can use, and then you can communicate over this ADS protocol into the different runtimes, and for example, get variable information or something like that. Okay, this is how it looks like in the engineering. Here you can set which core you want to have for the OS, which is maybe isolated, which is the base cycle time for the system here down to 50 microseconds. And then you can also set the CPU limits. So this was some short introduction about TwinCAT. Now let's talk about the new operating system. So why did we choose a new operating system, or why did we need a new operating system? So technically it was not necessary, to be honest. It was nothing which was technically driven. We doing that approach which I just showed since 1996 on Windows, and it worked quite well and successful. And the only thing which was now difficult is that Windows CE expires, and this is, I think it's an open secret, or maybe probably well known everywhere, that there is no real successor for Windows CE from Microsoft side anymore. So Windows IoT or Windows 10 IoT Core was on our side under evaluation for, I think, when was it released? I think 2016 or somewhere. But it was, or it's still very limited because it's still based on Windows 10, so it's still very big. It has a high requirements in regards to storage and RAM, and for us it was still too big for the small embedded controllers, and it's also very limited in kind of the CPU range. So they only pick certain CPUs which are available and where you can run it. And the next thing was that more and more customers are asking for non-Windows controllers, to be honest. So we have companies who have now new internal regulations or restrictions, and they say we don't allow Windows controllers on the factory floor anymore. So this was then the main reason then to say, okay, we need something else. Why did we now choose FreeBSD? Okay, to be honest, we started, of course, first to investigate with Linux. Like always, I mean, it's a very widely supported, especially from the hardware side, supported OS. But we got stopped, or we stopped very early because of the GPL. And so we tried to figure out if there are some hooks or something which you can do. We discussed it with legal department, with lawyers and everything. Finally, the problem is that no lawyer, nobody will give you final approval and say, hey, you can do it this way and you are always safe. There is no clear law or no clear case that you can do it in a certain way. So it's always a gray zone where you are working. And this is something which we do not want. The risk for the company is then too high. So I knew FreeBSD, to be honest, from my home server. So at this time, this is roughly 5 years ago, I was running FreeNAS on my home server, but I was not brave enough to propose it at this time. But in 2017 on the Asia BSD Con, Intel announced that they will support FreeBSD more. So they made a big spending to the FreeBSD Foundation, and they also started this FreeBSD working group, or this development group. And this was for us the initial step to say, okay, Intel is one of our major suppliers because we are mainly based on Intel CPUs. If they are now also supporting that OS, we can start working with it. So how did we switch to FreeBSD then? To be honest, we did not switch. We just added FreeBSD as another operating system for our real time. Yeah, so we are still keeping Windows, Windows 10, the big Windows. Of course, Windows CE is, yeah, somewhen expiring, but Windows 10, of course, remains. And of course, we are still supporting Windows 10 and working Windows 10 in parallel. But we are additionally bringing FreeBSD in the name of TwinketBSD to our product roadmap. Yeah, already 5 years ago, we started to make our real-time kernel, so the Twinket runtime, more or less independent by creating a platform abstraction layer. This is a driver which takes all the usual hooks you have into the OS. So you have all these, I don't know, things like PCI device search or some file I/O and all this stuff which you usually use from the OS. This went into the abstraction layer. And in 2017, we then started with the FreeBSD development. And now we have finished that. Of course, no software product is never finished, but we have finished that process, I would say. And our system is now built OS independent against this platform abstraction layer driver. So that means we have no external dependencies anymore. We have only this platform abstraction layer. And we can now just use a platform abstraction layer for Windows, which is of course different, and one for FreeBSD, but the core itself is the same. Yeah, so the runtime, the binary is the same. And if we would need to support another OS, which allows us to load such a driver into the kernel without major obligations, like releasing the source code, then we could do that as well. Yeah, so what does this driver do? So in fact, it just loads the Twinket runtime, which is a binary module, into the kernel memory. Then it sets up all the necessary environmental hooks. And in fact, then it's called this binary. And though that means also this binary is, of course, platform dependent or architectural dependent. So we need different binaries for different architectures. Okay. So the TwinketBSD base system is roughly, also our base image is roughly 300 megabyte in size because we're using package base. We decided to use package base because we wanted to strip down the system as much as possible, as well as to be able to update all the system components with package. We are using our own kernel also because the standard FreeBSD kernel didn't work out of the box. There are just some slight changes, which I don't know exactly, but I think there was something with the timer, with the internal timers. So it's really just a minor adjustment, which is necessary for us to run properly with our real time. That also means we cannot just install a Twinket runtime on a standard FreeBSD. We really need to have our own kernel. Yeah, and we have our own real-time network drivers for our used NIC network cards. Then we set up our own Beckhoff package server, where we are hosting our packages from our package-based system, from our Twinket world, so all the Twinket functions, all our packages, and we also mirror all FreeBSD packages. Yeah, so all the ports are also provided over our package server, so that customers don't need to use different repositories, especially because we have different dependencies. Yeah, so then it would be difficult if you mix it with a standard FreeBSD repository. Yeah, as I mentioned, Beckhoff Package Server provides for our customers the OS updates, Trinket updates, and all other package updates, which are just coming from the ports tree. As a file system, we are using ZFS because, yeah, we tested it a lot and we think it's a very good file system for our needs. Especially, we tested this power loss for a very long time, and after some yeah, issues which we found with the bootloader, so there was a smaller issue which is, but it's fixed now. It's now working without any issue, so we can use it for just switching off the machines. And this is in fact also a thing which a lot of machine builders doing. They're just switching off the machines, so they do not shut it down properly. They just have a main switch and it's switched off, and everything yeah, is switched off, and it has to work again if you switch it on. We also provide some other features of the ZFS file system with another name, because we are making it more simple way for customers. One is we call it Beckhoff restore points, or at least restore points. That means we are using or doing recursive snapshot from the whole pool, of course. This is no secret or nothing special. And then you can roll back to that point in time. And the nice thing here is that it's usually, if you're doing a recursive snapshot, you always have to do it with you can do it with this -R option, but if you're rolling back everything, it's quite more difficult, because then you have to do everything for every data set by your own. And we also created a restore boot environment, so that if the system doesn't start anymore, you can start into that restore boot environment, and then we have a simple command which you can use, and it's just rolling back to that restore point, and everything is exactly at this point in time. Another feature which we implemented is we call it write filters. This is known from the Windows world. So the Windows embedded operating systems offer that since, I don't know, Windows XP, I think, Windows XP embedded. A write filter is means it's like an overlay for the file system. So the file system is fully protected, and then there is just a RAM overlay, and all the writes are going into the RAM overlay. On Windows, that's getting tricky over time, because if you have a lot of writes going on there, it might happen that your RAM is overflowing, and then you have a problem. There's a reason why we are using now that, or why we are doing it here a little bit differently. We are not protecting the file system, because then you may also have issues, because some writes are then giving you, yeah, just the feedback, it's protected and I cannot write, so there might be errors. So in fact, what we are doing is, if you enable the write filter, of course we are creating a snapshot, and then we are creating 2 clones, and then we are always booting in one of these clones, and if the clone boots, it rolls back the other clone to the snapshot, and when the system reboots again, it's rebooting from the other clone. So it's always booting from the clean clone, I would say. So it's like a ping pong, and that makes it possible. And then you can just, yeah, you just say, okay, I want to freeze the system now, and then I can switch it off, do whatever I like, or if I do something wrong, I just switch it off, switch it on, and it's back at the same state. So it's something which also a lot of customers from us use in the Windows environment, and they also want to have that on BSD. And this is the way we did it now with BSD and ZFS. And probably we will also do other things in the future, but these are the two first things which we have now implemented. Next thing is Bhyve. Bhyve we also start working on to make to create an environment for the customers to use their Docker containers. So because we have really a lot of requests for Docker support from our customer base, of course we try to explain them that there are other technologies like jails, but yeah, sometimes there is maybe less knowledge and they just know the Docker name and say we need Docker. Sometimes they just have already implemented Docker in their internal environments and everything, and they just need that or want that to deploy their systems. Therefore, we are currently preparing a script, or let's say some kind of a button in our device management website, so that the customer can easily then set up a system or a Docker environment by we're creating a virtual machine with a small Linux image with a Docker engine inside, and then he can then install his Docker containers in that system. But this is not yet finished, and to be honest, we are open for discussion. So if you have other ideas, if you have similar issues, and maybe we also find a good solution for the whole FreeBSD system, that would be great from my point of view. Okay, last but not least, customer feedback so far. So we are in contact with customers since 2 years now. So for me, directly in contact with them, and until now, all of them appreciate a non-Windows OS, of course, and most of them also, give us a very positive feedback about FreeBSD as a base. So we have a lot of people saying, "Hey, FreeBSD, I used it in the past, but in my company we just use Linux." Nevertheless, they really appreciate that. Of course, we have these issues with Linux that customers require or ask for Linux so that they can run their Docker containers. But if we solve that in a different way, maybe with a virtual machine, let's see how we really solve that at the end, then this is also a no issue anymore. So and then we have really a good system where we really can satisfy our customers. Beside that, we're also doing a lot of education for customers about FreeBSD, because of course we always explain where we are based on, because as you have seen, we have a very open system, so it's not closed, so not like a PlayStation or something like that, which is completely closed, and you don't need to know what's going on there. Our customers want to know that, because we always sell an open system, because we want to make it open that customers can really implement new applications. Because if you close everything down, then of course the customer can also not do anything there. So also this was also in the past with on Windows, customers used the system also to add additional software on the system as well. And this is the benefit and the nice thing about the PC-based automation. And a lot of education also about FreeBSD as a Linux distribution. So you probably all know that, but really we have a lot of people thinking, okay, FreeBSD, that's one of the Linux distributions, and then you need to explain them, hey, that's not a Linux distribution. It's a full-blown OS, and Linux is just a kernel, and it's sometimes quite interesting to see the reaction. Okay. This was my last slide. So I hope I got you a small introduction to Beckhoff and how we use FreeBSD. Now I think we have maybe 5 minutes, I think, for questions. I just answer them here. So Warner asked, I wonder what stack they use for CAN bus. So the field bus stacks we are using are part of TwinCat. So CAN bus, Profibus, Profinet, which are developed by our own. So the stacks are not external stacks, so they are our own stacks. The next question, Sean. What security process technology do you apply on the FreeBSD based system? To be honest, I need to answer that later on. Of course, we are using PF firewall, so to really limit everything on the network side. Internally, we're just starting with Address space, local randomization. I need to figure out what else we are doing there. So I need to talk to the developers. Next question from Tommy. Do you follow current stable or release with FreeBSD source? So we are following release. Sorry, yeah, I think it's release. So because we're just switching now to 12.2, so we always use the latest released version of FreeBSD. That's what we are doing. Yeah, maybe we will change somewhere, but this is at the moment the plan, and yeah, which works quite well. Okay. Then I would say, oh yeah, you just took over. So yeah, then thank you very much, and yeah, I hope we can work more together then in the future. Thank you.
Thank you, Heiko. Oh, we have one more question, so I'll pop back over to you. Justin Gibbs had a question. If you're ready.
Yes. Okay, Justin, what is the rough split of deployments between Windows and FreeBSD? Is that trend changing? To be honest, we're just starting to ship next month, so I cannot tell you the split because there is no, or not the trend, because there is no trend at today. Next year, I may give you a better answer about that.
Okay. Thank you very much. Oh, let me make sure I do this right. Sorry, I'm getting used. We're still getting used to how managing Zoom. At least I am. Thank you very much, Heiko. Next up, we're going to take a 10-minute break before our next speaker gets started. So if you need to run, here we go. Yeah, Anne's going to start a timer. Now's your time if you need to run to the restroom or something like that. So we'll be back when the timer hits 0. Thank you. Hello, everyone. Welcome back from our break. Up next, we have Mohammed from Seagate, who's going to talk.
Hey everyone, I hope you can see my screen.
Hang on a second, I got to switch to you.
Okay.
All right, there you go. Now you're live.
All right, thank you so much. So let me actually start sharing my screen here and get going. All right, so thank you all for having me. It's always great to be here with you folks. I see a lot of familiar names on the attendee list. For those who don't know me, my name is Mohammed. I work in the office of the CTO at Seagate. My primary job is to just get our company moving in the right direction as far as open source is concerned. I also run the open source program office, where we try to figure out how we can best enable our engineers to be more productive with open source, but also going back to contributing to open source projects such as FreeBSD. We were really hoping before the COVID hit, and Deb and I talked about it, to have some sort of a meetup at the office we have in Longmont. That didn't pan out, but we're hoping that once this is all done, we will be able to host you guys. So with that, let me just get started. There's some legal stuff that I'm required to kind of talk about, mainly because I'm going to be talking about some things which may or may not pan out from a product perspective. So it's there for that. So we, in accordance with IDC, actually did a study on data and trying to figure out where the data sprawl is going. And that study is actually available on the website. Feel free to come download it. But basically what we found out is that very small amount of data is stored and most of the data is not. And we're just trying to figure out how we can enable more of that data to be managed and stored efficiently. But also my job at Seagate is to make sure we have open source ecosystems and open infrastructures in place to actually manage and store that data. And so I'm always looking at what projects are all in the pipeline, how we can use them, and also how we can enable others to use them. At the end of the day, it's all about the data that you guys produce and other companies produce, things like that. So I know most of you see Seagate as a device manufacturer, and on top of that, just an SSD and maybe hard drive manufacturer. But we have research going on in pretty much every level. So data creation, which can be, in many cases in the factories, or nowadays, with the cars and everything, how that data is moved, how to keep it secure. There's a whole lot of research going on in data provenance. So figuring out when the data is being moved, is it being tampered, making sure the fingerprints are on. How do you manage in such a large data infrastructure? Where can we help? Where can we learn from others? And then data infrastructure in place in general, how the edge is going to be and things like that. So all of that is in our wheelhouse. We always are talking to communities, those who are trying to create open source solutions for this, including you guys. And so we're always willing to do partnerships to see how we can help in this regard. So what can Seagate do as a device manufacturer? One of the things that I thought this community would be kind of interested to know, I think I have broached this subject before when I've talked to some of you. We are really pushing for hard drives to go NVMe native. And there's a lot of different reasons for it. Our vision is that data centers need to be a little bit more composable than it is today. So it's not always just hyper-converged. So storage being one part of it, but also memory as well as CPU compute can be more composable. And in order to do that, part of it is also about simplifying the stack so that you're not actually having SATA, SAS, and then now NVMe, different storage and compute stacks. So how do you want to consolidate all of it? So we, looking forward in the future, are really pushing for HDD to go native NVMe, and we have partnerships with other vendors that are part of the stack in order to simplify that. We are working with standard bodies trying to actually implement some of the standardization that is needed. So how does it matter to the FreeBSD community, and how you guys should think about it. If you are in the stack which talks to NVMe devices and you think that's going to be a fast flash-based device only, which we also produce, by the way, but if that's the assumption that you're making while writing your device driver or your block layer scheduler or something like that, I request you to think a little bit outside the box, because we are really hoping that the command set and the stack gets consolidated. And so it's not so much, people are now managing different, not only software stacks from an OS standpoint, but also for the hardware stack. And I know any software, I've written a lot of software, there are a lot of assumptions that go into it. So knowing the fact that these might be coming down the pipe, we're really hoping that, we're not going to get blocked off from a software side of things. We created a TPAR in the NVMe standardization body that got, I think, approved in OCP, which is an Open Compute project. We're presenting on Friday to talk some more about it as well. So you're welcome to come and be part of that as well. So I don't have a date for you. I'm not from the product side of things, like when you will have a native NVMe HDD available, but at least we can, we are from a vendor perspective pushing towards that. So the other thing I think I've talked to you guys before is dual actuator. So the motivation there is that as we grow in capacity, which if some of you may be aware, some of you not, we released the 18 terabyte drive, which has 9 platters and 18 heads. It's a very complicated beast. But at the same time, the pipeline that is going into that hard drive is the same, which was a few years ago. So basically your IOPS per terabyte are getting lower and lower. So last year we released the Mach 2, which is a dual actuator. It has gone to the satisfactory launch that we thought a new innovative product would do. I think I've talked to some of the people who are attending this today about how we can make it easier for FreeBSD ecosystems to consume the dual LUN device. What I wanted to tell you guys today is that we're working on a SATA one coming pretty soon. Currently, it's already being standardized in the ACS specs. I believe there's some discussion going on in the SAS spec to kind of make sure that the single LUN SAS would work out just fine. And where the complications come in is how the data is laid out. So imagine if you have just one LUN or a SATA device with multiple actuators in the back, how does the device tell the software stack how many actuators there are, how are they laid out? Would you want the control plane to actually look at the device and then make the decision on their own, how they want to lay out the data? Do you want the device to kind of figure it out on their own? So all of those are being discussed. But definitely we are going down that path, and we will have something for SATA pretty soon for people to kind of play out with. For the Mach 2 that is currently out there, there's still work being done. I think we're working with some of the other communities like Linux community, trying to figure out some of the storage block layer schedulers can be improved for a dual LUN, because again, going back to whenever we were writing software, we always have assumptions. And the assumption back then when they wrote those schedulers was a single LUN, a single spindle. That is not the case anymore. So going forward, how do we handle that? Another thing that ties back to the NVMe has a whole concept of namespaces, and we're exploring how those namespaces and actuators kind of mesh together. Love to talk to you about it later. I know this is a whole topic on its own. There are people who do, an hour-long presentations on how we have created this this infrastructure, and then how we can people want to know more about how the actual drive works and things like that. So with that, let me talk about something that is dear to my heart, which is observability. So first, let me just go a step back. Just talking to anybody who is working in the data centers, having an autonomous data center is a nirvana everybody wants to go towards. There's a lot of open source software you guys probably are aware, like Prometheus, Grafana coming out of CNCF. They're all about observability. I see a lot of active monitoring of devices going on, as well as at a higher level. Everybody wants to know what's going on with my storage stack or the whole infrastructure. And all of that depends on having the devices at the very end, be it, storage devices, network devices, RAM, anything, producing the kind of telemetry that can be monitored, observed, and then decisions being made at an autonomous level. So we understand that there is a need, and we're trying to figure out how, as a storage vendor, we can promote some of the stuff that we have in our devices. And especially since our devices become more and more complicated, as the devices are like, 20 terabytes, 24 terabytes, 30 terabytes, we really want to know what's going on in the device. We want to monitor it closely. If you are, storing that amount of data on the device, you want to know where your data is and how it's being stored, and how the health of the device is. What is the workload like? So this is a grand vision, not necessarily where we are right now. As you may know, there's people like Blackblaze, for example. They share some of their data, and many people download that data and make a lot of assumptions on it. If you are involved with any of the research work with Usenex and some of the other things, you would know that people take the data that Blackblaze is sharing and try to make a lot of data analysis or models out of it. The fear there is that that's only one skewed look at the way devices are used. So what we have done, just to enable, the bigger vision is that we want to make it as open as possible. People sharing their data, we're hoping to partner with foundations and universities who are willing to host some of this data so that other data scientists can come in and take a look at it. So imagine if you had very detailed data about, at the device level, CPU utilization, RAM utilization, all of that. And then you can create data models based on that. How do you want to tier your data within an infrastructure, or even trying to figure out how quickly or how predicting some of the device failure type of things. Those are all the things that we would like to enable. So if we had a log called farm log, it's just a field, reliability management type of log. It used to be under NDA. So we worked really hard with all the people involved that was pouring information into that log and scrubbed it, and now it's totally open. So it's published, the spec is published on our GitHub page. I know some of you are thinking, why not just make it standard, like a smart or something like that? If any of you have served in any of the standards body, you would know that it's a really hard problem to solve. There's a lot of people trying to do a lot of different things. So since we had something that we could quickly enable by opening it up, we have actually done that. We have actually created tools and parsers that you can use, which, by the way, work in FreeBSD, that can parse the data that is coming out of these devices, especially these are nearline high-end devices. And so you can actually see what's going on. There's workload statistics in there. There are head level statistics in there so that you can actually see if a specific head is, getting more degraded than the rest of the device, things of that nature. But what we really hope to do is that more and more people start sharing the data. A lot of them, by the way, share it on a one-on-one basis with Seagate, and we provide them insight. But then again, it's a very one-on-one relationship in the spirit of openness and trying to actually be more transparent. We would love to partner with foundations that are willing to host such data, and then create tools and infrastructures in place for people to opt in, sharing that data in a very open way with some of the licenses, which are all about, hey, come take the data and actually create some models for it. So we do have some things in the works that we're hoping in the future we can open, which is data models and inferences. But I don't know how far they will go, because some of that data that is used to create those is not open. So we're really hoping to get some partnership out of it. If you're interested in this topic, feel free to reach out. I would love to talk to you some more about it. This is my last slide, and I'm hoping to kind of tell you about what else have we been able to do. There is a project called Cortex. We have open sourced it back in September, so it's fresh off the press, so to speak. more than 1 million lines of code. It's an object storage. So we had an object storage for our own products, and after a long internal debate, the executive team agreed that it will be best that we totally open source it. So it's a Apache-based software-defined object storage. All of it is available on our GitHub page. The community of engineers that are backing this are really excited that Seagate was able to open source it. I've talked to them. They're always willing to help. Currently, we have some major dependencies that we're trying to solve, and that's why it doesn't build on FreeBSD. I'm hoping in the future when I come back and talk to you guys, I can report that it does build on FreeBSD. Currently, we're using Lustre and some kernel modules, which are very much tied to the Linux kernel. And our hope is that that dependency breaks sometimes next year, and we're hoping to actually be able to then build on other operating systems as well. If you are interested, if this is something that interests you, please feel free to come and just create an issue. Just say, hey, I would love to have this built on FreeBSD on this, so that our engineering team also gets an idea that there is an interest. At the end of the day, it's a software stack that allows you to have an S3 plug, so to speak. So when you run Cortex on on a platform, one of the what you can pretty much do what you do in an AWS S3 bucket. Nobody kind of covers everything that S3 AWS provides, but we have a good coverage of that protocol available. In the future, we're thinking about adding some more file and block layer type things to it. So I wanted to mention it, even though it doesn't build on FreeBSD today, just to give you an idea that from a company standpoint, we're really hoping to open more and more of our software assets. We are in the right direction and hoping to partner with this foundation and FreeBSD project in general a lot more. So with that, that was my last slide. I think I see one at least question. Do you think NVMe hard drives can meet same cost as SAS nearline? So we really hope that that would become the normal case. In the beginning, we will have, we're hoping to have enough partners in play to create a competitive product for the nearline side of business. But overall, in the end, SAS is not going anywhere anytime soon. So both nearline SAS and NVMe would probably go hand in hand. I'm hoping the cost would be like, hey, whichever infrastructure you're comfortable with deploying and how mature the rest of the stack is, that people will make those choices based on that. So I don't know what I'm doing on time. I think I'm a little bit early, so.
We do have another question in the that came in from YouTube. If you want to check out the chat, Ed posted it.
Okay. Annie, if you want to just say it, I can just kind of reply to it that way.
Okay, I can give it a go. They ask if there's any information on a slower perf on Mach.2 drives under ZFS on the second LUN.
Okay, so I think I see there's a slower perf on Mark II drives under ZFS on the second LAN. Okay, good. So I think this is coming from the ZFS folks. We had a, by the way, for those who don't know, we had a hackathon last year at the OpenZFS, and I had some servers running with the Mach 2, and we noticed that there was a discrepancy on when you're running IOs on a Mach 2, which has 2 LUNs, that the LUN number 0 was faster than LUN number 1. So that's for those who don't know the issue, what we're at stake. So basically, currently, since it was single port, the answer that I got from the R&D team was that there's a hop involved. They are convinced that that hop should not have the skew that we were seeing between LUN 0 and LUN 1. There was a good bit of investigation that went into it. So basically, because there is a single port, all the commands go to LUN 0 and then hop to LUN 1. And therefore, one of them is a little bit slower than the other. They tell me that with the write cache enabled, that problem should be much more better. It's on me to actually go test it. I just haven't had time to go test what the new firmware and the new, newer versions of the Mach 2 have come up to. So I'm hoping to give you guys feedback in the future. All right, so the question, another one that came in was, is Seagate working with Gen Z consortia on fabric solutions? Absolutely. So we're part of both the Gen Z and CXL. We believe that that's where the composability of the data center really lies. So we're working together with them to see how memory can be addressed in a composable way in a data center, as well as how storage is. My personal opinion, not Seagate's opinion, I think CXL would probably be get there quicker, and then eventually we will get to Gen Z. All right. Hard drives have difficulty filling even a single PCIe channel. What's Seagate's view on that? Will be connected to the host. So we personally think that it's not going to take more than 1 or 2 PCIe lanes. And so the way we're envisioning is that if you can remove some of the complexity in actually supporting multiple SAS in the same infrastructure for PCIe, and we're hoping in the future people will create architectures where they can, they can let one of the lanes or 2 of the lanes go to hard drives. And I think there are people way smarter than me in my group that are working towards trying to figure out how to enable that hardware piece. And hopefully that's where we're trying to actually go to some of the open consortia and trying to actually hash this thing out. I believe now there's enough momentum. I go to them enough. When we were talking about NVMe HDDs a year and a half ago, we got a lot of pushback. Now it's actually being debated in the right places, so to speak. So I think I see a good future. I mean, it's going to actually happen. All right. I see that's the last question I had.
Yes, I think we're good. Thank you very much, Mohammed. Cool. Thank you very much for coming again this time. I think now we're headed into our next 10-minute break. And after that, we have a talk from ARM. So another 10-minute break, everyone. Okay, welcome back from our break, everyone. Up next, we have a talk from Andy Waffa from ARM. So I'll hand it over to Andy. Just a second. There you go. You're live. I think you're still muted.
Am I?
Oh, nope, no, you're not.
Nope.
All right, I will be quiet now. Go for it.
Thanks, John. So let me just. So thanks, everyone. I'm going to run through some upcoming architectural features from ARM. Whilst I'm presenting it, there are much greater minds than myself behind the scenes. So do bear with me. So as I mentioned, run through some of the new architectural features in ARM v8, so ARM 64 primarily, and there's quite a bit here, so I will rattle through it. Obviously, the slides will be made available at the end if you wish to peruse in more detail. One of the caveats is a lot of the examples that will be given are on Linux, unfortunately, and not on BSD. We're hoping that that will change in the future. The definitive reference is the ARM, so the ARM Architectural Reference Manual, which is freely available to you. So things that I'm going to look at covering is from ARM 8.1 through 8.5, and a little sneak peek of after 8.5, so large system extensions, persistent memory, SVE, scalable vector extensions, profiling, nested vert, some security features like pointer authentication, memory partitioning, memory tagging, and beyond the horizon with transactional memory. So large system extensions, LSE, you'll see from the title there, we've implemented a new feature nomenclature. So features are categorized as feat underscore whatever the feature is. So as you can see here, LSE allows atomic operations in a single instruction, and it also allows the system to perform the atomic operations outside of the CPU. The atomic operations are rather fundamental, so you can't really select them with hardware capabilities or iPhones. There is a multi-lib mechanism, primarily in glibc, that supports the hardware capability underscore atomic, but that would provoke multiple binaries, so resulting in multiple builds. Best ways being developed, so GCC 10 and GCC 9.4, they've got support for outline atomics. Performing a direct branch to select the appropriate code sequence at runtime as a result of the outlines. And we've run practical tests on things like DPDK, lock stress test harness. That shows very little performance degradation. The outline atomics are currently in progress for Clang, not quite there yet, but it is in flight. And QEMU 3 and above does support emulation of the LSE extensions. Persistent memory with the point persistence and deep persistence. this is required, you know, for the ARM64 kernels to pick up NVDIMMs, and the firmware needs to expose the requisite NFIP through ACPI. An example for SVE using LDFFlib. If you look at the example, we've got block of memory 0.2 by x0, but as it crosses a page boundary and the next page isn't present, there's a chance that it will fault on access. So the register P1 is a predicate register. It dictates which lanes are affected, and then sets the lanes to 0 that aren't selected. Results stored in Z0, and which is a SVE register, and the number of lanes is implementation defined, but it's discoverable at runtime. And so the example here, the instruction won't actually provoke a page fault if it loads the first lane successfully. SVE is an optional feature in ARM 8.2. It does add another set of registers, Z0 through 31. So that's the lower 128 bits of the map over to V0 and V31. The size is implementation defined. It can vary from 128 bits to 2048 bits wide. Currently, the Fujitsu A64FX SoC is the only silicon available at the moment that has SVE. There are others in flight, but the A64FX is the SoC that actually powers the Fugaku supercomputer, which is the fastest one in the world at the moment. Not just fastest ARM supercomputer, but the fastest. And so the predicate registers 0 to 15 have also been added, and so 0 to 7 can be used to affect how the instruction operates, and they're effectively governing predicates. There's first fault register as well, which is used to handle crossing memory page boundaries. And all of that allows one to program SVE without knowing how big the vector widths are, or even how big the array of data is at compile time. In other words, there's a load more scenarios where SVE can be applied to where the existing Neon instruction set wouldn't be suitable. So things like string handling. But SVE is significant enough that I could get somebody from our toolchain compiler team to go on about it and for at least an hour and a half if you so desired. So in this string length example, it just shows another way how SVE can be used. As I mentioned, I'll be rattling through fairly quickly, so you can reference these examples afterwards. So support for SVE, it's supported in GCC 8.1 and above and LLVM5. Auto vectorization is expected to improve as each release comes out. So Linux supports SVE from kernel 4.15. SVE2 is slightly different, and that's able to be handled by user space from, or passed through to user space from kernel 5.2. And QEMU 3.1 has full support for SVE. ARM have also developed an instruction emulator based on Dynamo Rio, which is freely available, and that has full SVE support within that. And some of the commercial compilers do also support SVE. The intrinsics can be used rather than the assembler, and if you so desire to do that, if you pop over to developer.arm, you'll be able to get the documentation telling you how to do that. So statistical profiling extension, another optional feature, some for 8.2. So it's taking the PMU and sampling it in a more traditional way. It relies on interrupts rather than the, so then kernel can gather all the data needed. The statistical profiling extension gives a contextual information for the actual event and can sample everywhere that's allowed by the by whatever security has been implemented. SVE is accessed in perf, so if you're using perf, that's how you go about accessing it. And so that the support landed in kernel 4.16 with perf, and it supports ACPI from 5.3. So it's all available now in the upstreams. Nested vert is an optional feature again. It was introduced with 8.3 and is enhanced even further with 8.4 with nested vert 2, which removes a lot of the trapping. The support within Linux, primarily KVM, is still being developed, and there are patches waiting to be merged upstream. So it's still a somewhat moving target, if you will, and it's not quite been finalized. And it would be something that we would like to see ultimately within the likes of Bhyve. Point authentication, and so it's possible, or it may well be possible, to overflow the stack buffers with a payload that is controlled. On ARM, neither stack nor most of the data buffers are executable. If you look at the above example, though, you could control the value of X30. Thus, you could, in theory, dictate control flow to resident code, so something like glibc routines. Suitable routines, commonly known as gadgets, can then lead to a Turing complete exploit within the data buffer, somewhat termed as a return-oriented programming attack. So that's what we're trying to solve with point.auth. It will be more commonly known as PAC within ARM. It was originally known as pauth, but that's somewhat changed to PAC now as the common name for it, which effectively means that the pointers are cryptographically signed, and that was introduced in 8.3, and so that provides a means to protect the pointers from outside manipulation, as per the previous example. You can have an optional modifier to use as a salt for your pack. So before being used, pointers authenticated there and then. If the pack bits are valid, your upper bits are going to be cleared, leaving a valid pointer. Otherwise, an invalid pointer is returned, and that will just result in translation fault. So here's another example, just to explain a bit more with how PAC works. To help with the deployment of PAC, some of the instructions are in the NOP space. So that means effectively that systems without PAC won't be affected. And so when you try and run the point authentication, it will just be interpreted as not and not impact. So within Linux, it was introduced in kernel 5.0. There is detailed documentation available, and you can query point authentication in user space as well to find out whether it's present and whether the functionality is present. The kernel does, or Linux does, provide a mechanism to reset point authentication keys of the process to new values. From user space, point authentication's available, but you do need new versions of GCC as well as binutils and GDB for debugging. LVM8 and later does support point authentication, and QEMU 4 and above also supports emulation of point auth. So expanding on the whole point authentication, as that can mitigate against ROP style attacks, it doesn't mitigate against jump orientated programming. So it's possible to affect the control by targeting indirect branches. So a chain of gadgets can be formulated. These branch targets are not necessarily persistent across functions, so they can't be authenticated. However, we can mitigate against some of these jump-oriented programming attacks by restricting where the indirect branches can land. And so in ARM 8.5, we introduced the branch target identifiers, commonly known as BTIs. And so BTIs help restrict the targets for the indirect branches. And so to be able to do that, both user space and kernel need to be involved. So from user space, BTI instructions effectively landing pads for the indirect branches, and these are also in the NOP space. And so initial support landed in GCC 9.1 and binutils 2.32. And you can commit BTI instructions relatively easily. From the kernel side, memory pages do need to be marked as guarded, and this is achieved by setting bit number 50 in the stage 1 page table entry. So here's an example of BTI in use. And moving on, there's memory partitioning and monitoring, so MPAM. We do like our acronyms. And so MPAM allows you to partition the L3 cache. This can then provide more predictable performance for some tasks, and it allows you to monitor the memory traffic that's going through. So you can check on the memory usage of specific tasks. Memory tagging extensions is introduced in 8.5 to protect against buffer overrun and use after free space. And you know, a physical address tag is effectively signed with 16-byte granularity. Sorry. The physical address is then stored in memory, the tag of the physical address is stored in memory, and the logical and physical address tags are then tag checked with an exception and can be thrown on a mismatch. Tag checking. Three kinds: no effect, synchronous exception, and asynchronously accumulated. The synchronous exception failure is more expensive than async, but it does give you extra security. So you choose which you want for the use case. MT emulation is available in QEMU from QEMU 5.1. And thanks to our dear friends Spectre and Meltdown, there are additional options to mitigate against speculation side channel attacks. So speculation barrier, speculation store barrier, bypass safe, and predication invalid. The following two features are mandatory in both ARM 8.0 and 8.5 as far as speculation goes, to try and minimize any of the impact. And they provide system registers that are available across ARM implementations. Transactional memory extension. Provide strong isolation from a hardware perspective, failure atomicity, and the best effort transactions. And as an example for public documentation of some of the new technologies, this is how it would look when you're going through the docs. Morello is our implementation of the Cherry architecture from Cambridge. More documentation is available and more details, and there is a system being worked on. And if you go to the link here, you'll be able to see that in action. So it's a capability system where pointers are extended to 128-bit plus tagging bit, and those extra bits are used to store the various capabilities, and those capabilities are unable to be forged. They can be copied freely, and all rights can only be reduced, not increased. And importantly, legacy code can be compiled for AR64 execution and can be run on the Morello platforms. So putting to a pure Morello code base can be more than just a size of change. And so I've got a raft of links here and for references for you to read at your leisure. And you can see there's plenty there, including a couple more on Morello. And that's about me. Any questions?
I have not seen any questions yet, and I'll give folks a couple of minutes to ask.
I appreciate I rattled through it at a rate of knots.
So someone did ask if slides are available, and I can answer that one. Our plan, as usual, is to ask all the speakers to provide a copy of the slides that they're able, and we will then link them to the DevSummit wiki page, so you'll be able to get the slides from there. Sorry, I have to check IRC over here. Okay, well, I think we're probably good for this session. Thank you very much, Andy. I think we're ready for our next break. Here, let me switch the video over. Well, we have another break coming up for a few minutes if you need to run to the restroom or something. And after this, we'll have our first discussion topic where we're going to have a group of folks as a panel to talk about future directions of ARM64 on FreeBSD. And we'll have an adventure as this is our first discussion group. We'll see how this works. Should be a lot of fun. So we'll see you in a few minutes. Okay, everyone. So next up, we're going to have our first discussion topic, and we're going to be having kind of a roundtable discussion to talk about ARM64 on FreeBSD. So we have several panelists here. If you guys want to kick on your videos, I think Ann's going to fix it so that it will bounce around to whoever's talking. I might have to stop being special. Yes. It's chosen you, Andy, but if folks can try unmuting and talking, we'll make sure it bounces around. And then I'm probably going to turn it over to
Hi, John.
Ed. Yes?
I just said hi, John.
Okay. All right.
See
It's
it.
moving around.
So
I'm going to let you drive, Ed, and I'll be quiet for the time being.
the intent here is that this session will work the way that we've done working groups for in-person sessions. And what I'm going to do is I've got some slides here that kind of talk about, or we can use as starting off points for discussion. But we've got Mark Johnston, Mitchell Horn, Andy Turner, and Andy Waffa on as well, that we can basically just, it's a roundtable discussion. We'll look at questions that folks have and figure out where we go from here with respect to FreeBSD and ARM64. So let me just bring up the slides and share those.
And one thing I might say while you're doing that, Ed, we might try something different. Folks can ask questions by using the Q&A feature in Zoom, or I'll try to keep an eye on IRC and Slack. But also, if you're an attendee, if you want to like verbally ask a question, you can. There's like a raise hand option, and what we're going to try to do is, if you raise a hand, we'll try to unmute you and let you talk, so you can kind of interact with the panel, and we'll see how this works.
Here, all right. Let's see. All right, can you see those? We'll go into presentation mode. All right, can we see the slides on there?
Yes.
Okay, great. So very briefly, some history of ARM64 support in FreeBSD. Andy Turner started the work in the FreeBSD community in 2012 after upstream toolchain support started landing in GCC and later in LLVM. A couple of years later, he was at the point of getting to mount root, so most of the kernel requirement, the necessary kernel work was done, and then the foundation, FreeBSD Foundation, stepped in to coordinate the work that he had started, as there were some folks who wanted to fund extra work to really move things along, and so the foundation coordinated Andy and SemiHalf's work with funding provided by Cavium, ARM, and the FreeBSD Foundation to really move things ahead. And that got us to the point of having ARM64 as a supported architecture in FreeBSD 11. And then I think it was still at the point where it was, maybe you would describe it as a technology preview. There were many things that weren't really working all that well, but it was in there and available for experimentation. And then FreeBSD 12, which released in 2018, really was kind of the first. 12.0 was the first release with really usable and reasonable quality ARM64 support. We added LLD as our system linker, so we had a fully in-tree toolchain. During ARM64, FreeBSD ARM64 development, we were relying on an out-of-tree or linker rather, so we were using an up-to-date bin utils, but an in-tree Clang for much of the earlier development. But then with LLVM's linker, we got to the point of having a fully self-contained toolchain, and we're able to treat FreeBSD, ARM64 in FreeBSD as any of our other architectures. And at this point, in fact, all of the FreeBSD architectures in tier 1, tier 2, and tier 3 are all using Clang, LLVM, LLD as their common toolchain for all of those. Andy, anything you want to touch on briefly on the history?
And I think you covered it all.
So the point of my session here really is to talk about what does it mean to get FreeBSD ARM64 to tier 1. And this is in the context of FreeBSD 13, which is next year's release. And so I have a link there to the what the FreeBSD project defines as our tiers. There's sort of some unwritten connotations around what it means to be in a tier as well, and so we'll allude to some. We'll get to some of those in the discussion as well. But the main point is that the tier 1 architectures today are AMD 64 and i386, and basically it's the most well supported. All of the kernel functionality, userland functionality, ports, security team support, all of those things are factored in or make an architecture tier 1. And then moving down, we get into architectures that are either some functionality is missing, they're not really commercially relevant, things of that nature. And I'm not going to talk really at all about tier 2 or tier 3. The goal here is to move ARM64 up to tier 1. So I've got some slides here that talk about what the project defines as the guarantees that we provide for various tiers, various aspects of the tier. And so the first one, I've reorganized some of these. I've basically taken the list of what we document as the expectations you can place on each of the tiers, and I've sorted them out, resorted them a little bit to take points that are more closely related into individual slides, just because the list is quite long, and they don't necessarily, the list as it is on our website doesn't necessarily lend itself directly in the order they are to looking at them in groups. So the first item here is around the tool chain, and this basically says that the architecture should be able to build itself, or in the case that it's not really not really feasible, that there is a straightforward way to do it. So we don't rely on, needing we require that building an architecture doesn't involve some specialized tool chain that has weird patches that's hard to install. The ideal case is that the tool chain is included in the tree and is built as part of regular build world. So ARM64 meets all of the 3 points here. It builds using the Clang and LLVM, LLD toolchain that's included in the tree. ARM64 support is part of the main FreeBSD source tree. All of our supported architectures actually are included. We have no architectures that are that are in these in the reported tiers that are external. We do have some downstream projects that are not listed as parts of these tiers that have their own separate trees. And then the Universe and Tinderbox targets, those are sort of the standard build sanity check. And those for ARM64 is one of those. Anyone else on the panel want to comment on any of these? Okay, then we'll go next to hardware, and this is primarily around having access to hardware of the specific architecture within the FreeBSD environment. And I would say that so we do have ARM64 hardware in the FreeBSD cluster right now. We have some ThunderX machines, original Cavium ThunderX machines that are not working particularly well at the moment for a variety of different reasons. We have some issues with getting packages built for ARM64 at the moment, but we do have some eMag systems from Ampere on the way. They've been ordered and are on their way to the data center to replace the existing ones, which will allow us to restore the ports package building environment. So we will basically be back at least where at the baseline of being able to build packages on an ongoing basis, so that we'll have a reasonable set. So I think there's not really anything that needs to be done or discussed for this item. It's in progress and will be restored soon. Any other comments?
Yeah, the added advantage as well is that there is more, or there are more systems becoming available as time moves on, both from an enterprise perspective and also from a consumer perspective. And so the chances or the availability of hardware should be a little bit easier.
Yeah, I guess one important point in this this topic here, and it's something that the FreeBSD project hasn't done very much of historically, but at this point, it's actually quite easy to bring up a development environment for FreeBSD ARM64 using Graviton instances on AWS. Mitchell, I don't know if you have if you want to comment on that briefly, because I know you've done a bunch of development using that scheme.
Yeah, it's pretty good when you get past the initial setup. As long as you aren't doing anything where you might need early console access, it works well, and you can scale your machine up or down kind of depending on what you need. So if you start out with 4 cores and a little bit of memory, and you say, oh, this just isn't building fast enough, you can kind of change things that way, swap out storage. So I've been using it for a couple months, and it's been pretty easy to learn and convenient as a development platform.
And I think for anyone, I mean, your comment about early console output, for anyone doing userland development or kind of anything other than low-level ARM64 kernel work, I think that's not going to be a limitation really at all.
Yeah, even something like if you wanted to build your own ARM64 packages, customized packages, I could see it being useful for that and easy.
Yeah, I know there's some work in progress to do some tooling around using cloud resources for FreeBSD package builds for not for the official packages, but for developers or downstreams who want to build their own sets for various reasons. All right, next item on my list is around release artifacts. And I think, again, we've got 3 items here that are already the case. So release images will be provided by the release engineering team. FreeBSD RE has been producing release items, release artifacts as of FreeBSD 11. As I mentioned a little while ago, we added ISO images most recently, and that's I guess they were never added. We never produced ISO media for ARM64 in the past because we assumed that there would be no need for it during all of the bring up work. But with the proliferation of server hardware that looks very much like what you'd expect from a commodity x86 server, where it's got a BMC and can do virtual media emulation. For the ISO images are there's a reason to use them, even if we don't expect to actually see a physical CD-ROM drive in one of these servers. But the other media has been produced for quite some time. So that's complete. Binary packages for third-party software, i.e. the ports collection, aside from the fact that we've had some hardware trouble, once those new machines are in place, we'll be natively building ARM64 packages. And I think the machines that we're installing are maybe a little bit slower than the x86 package builders that we have, but they're in the same order of magnitude as far as the build time. So we'll be able to produce those on the same kind of weekly package build cadence that we do for x86. And the last point here, I think there's ongoing iteration to find ports that don't build on ARM64, and either addressing them or enabling them or determining that they're not relevant and removing them from the list. I think that this is, I guess, one of the areas where we've had some discussion in the past around what it means to be a tier 1 architecture, and is it a requirement that all of the packages build, or what is the threshold for package availability for a tier 1 architecture? And I think it's at the end of the day, it's inherently going to be the case that there are some packages that are relevant to an architecture and some that aren't. I think historically we probably were less interested in kind of end user desktop type packages on ARM64. That might not be the case moving forward, but as long as the packages that are relevant to a workload that someone wants to run on FreeBSD ARM64 are available, that's kind of the important point.
I do have a question that's kind of relevant from YouTube, Ed.
Yep.
Mirror176 asked, do ARM FreeBSD releases need a different image per device, or do you expect that you can have like a fairly, like just how in x86 we have a single ISO? And I know this may be different for 32-bit ARM versus 64-bit ARM in FreeBSD's world. Although even in 32-bit ARM, I feel like we're no longer make 47 release images. Yeah,
that's a good point. And this discussion, I'm focusing specifically on 64-bit ARM, and I'm not quite as familiar with some of these aspects of 32-bit ARM, but in particular, we have no goal of moving 32-bit ARM to tier 1 status. I mean, we definitely want to support it, I think, as well as we can, but the focus really is on 64-bit ARM as a tier 1 contender. And to that end, the release artifacts that we produce for 64-bit ARM, so we do produce a same as x86 or same as AMD 64. We produce a memstick image and an ISO image and virtual machine images, and those images the same image and the same generic kernel will work on the Cavium ThunderX machines, on the Ampere eMag, on the Graviton instance, and perhaps with a small amount of configuration on some of the 64-bit embedded boards. The main difference I think that's needed on the lower scale, hobbyist or embedded boards is that they might need a board-specific U-boot added to the image. It's often possible for that U-boot component to reside in some other storage, in which case the same, where FreeBSD starts with loader.efi. We boot via UEFI, and loader.efi is the kind of the beginning of the FreeBSD boot process. And from that point on, it's the same code across all of the ARM64 targets we have. I'll let Mitchell or Mark add any other background there if they have something else to add, or Andy.
I think there's two things you have to think about with it is two classes of machines. There's the more server end machines, and they are all fairly, and that includes some of the desktop, something that you might see as a desktop machine as well. And that they're fairly standardized, and that they'll probably have UEFI, which will come from an EDK2 or similar UEFI. That will come from be built into the machine somewhere. It will be on a ROM or a flash memory on the machine. And then there's more the embedded class things, which we need an image for each, or we often need images for each type of machine, because they need a custom firmware edit that they load from say an SD card or whatever media you're booting from. And so it's easier to support the server machines, and there is work on having a single image for the smaller machines as well, which you then have to put your own U-boot on. But it does require, it depends a little bit on exactly what layout each SoC requires. And there is some work from ARM to try standardizing this with the EBBR, the embedded boot. I can't remember exactly what the B stand for, requirements.
Base boot recommendation.
Yeah.
And SBBR, right?
Right, and so SBBR was the original base boot recommendation, server boot base boot recommendation, which tried to standardize a lot of the vendors on EFI, because originally a lot of the server vendors were coming from embedded space, they were new entrants, etc. So they didn't quite grasp how to have a single boot image. And so we at ARM tried very hard to ensure that people got on board and got on message, which thankfully they did. And so a single EFI build should boot across platform from Marvell, Ampere, Fujitsu, etc. AWS. That single image will boot across all those different platforms. And when it comes to more of the embedded space, EBBR is trying to replicate what was done in the server space and try and unify a lot of people on a single bootable image. So work is ongoing. It's not there yet, but it's in the right track. And ultimately, that should work across operating systems, regardless of whether it's FreeBSD or others. And so it's certainly within the realms of possibility. And I know kind of mentioned on one of the questions is anyone tracking system ready? And system ready is absolutely the right thing to be following when it comes to generic images and validation. I'll leave that to Ed and Andy and team to advise as to what's being done on the system ready front. But that is certainly the right path to follow.
Yeah, I mean, I think the short answer is that yes, we will we'll do the work to work in that model. That's what I expect we will plan for FreeBSD 13. The foundation is undertaking an effort to fill in some of the gaps on ARM v8.1 plus. So all of the kind of extensions, we're gonna tackle the tackle the features that are of importance from there, as well as features and development that isn't directly related to one of the specific ISA levels, but just kind of general functionality that that we need to support in time for the release as well.
I guess I'm unmuted.
Yeah.
Hopefully this is the right microphone to talk into. I had a question for Wafa, which was, what's the timeline for that boot environment to be available in hardware? And also to say that there have been efforts from time to time to try to get enough metadata into the U-boot ports so that we can do the bring your own U-boot thing for the more legacy ARM64 and ARM32-bit platforms as well. So for the older ones, we're not there yet, but we're making good strides. And I would love to have one that would just make this work obsolete entirely. So.
Warner, are you talking about the 32-bit unified boot model or the 64-bit?
The 64-bit one that you were talking about, working with different SoC vendors to adopt for a single image across them all. So the might be interesting, but that's the one I'm most interested in.
Right. So that for the 64-bit stuff, as long as they're using EFI, immaterial what the platform is, you should be able to just take an EFI enabled image and boot it on any of the systems. That's at least what's happening in the Linux space. So you can take any Linux distro image that's EFI enabled and just boot it on any of the platforms you have. That can even work on Raspberry Pi as an example, because the U-boot for Raspberry Pi now acts as an EFI loader.
Right, but you have to put a specific version of U-boot onto your boot media for that to be enabled. And I'm hoping that we don't have to do that for each of the different boards in the future.
Right, so from a server space, there's no separate one because they're all using ACPI now. When it comes to Raspberry Pi, that's you shouldn't need to have a specific U-boot. You should just be able to take default stock upstream U-boot and off you go.
But the U-boot compiled for Raspberry Pi won't work on Rocket Port or vice versa, or Allwinner. We still have to have a specific early initialization code installed onto the boot media to get to the EFI part. From the EFI part on is great. It works, but up to that point, it's still kind of specific.
Right. Yeah. So from a
and that's the part.
Yeah.
That's the part I'd like to go away.
Yeah. You might have more luck with lottery numbers, I think, sometimes.
Okay.
Unfortunately.
That gives me the context to know whether or not I should abandon the stuff I've started, and it sounds like I should not.
Yeah, please, not yet.
Okay.
We're hoping to get there, but it's a slow process. And work is ongoing. Linaro are trying to push things forward with the EBBR spec and get people on board and remove the requirements for custom U-boots. Just have a single U-boot and off you go. But no,
okay, thanks.
Not here yet.
Okay, thanks.
Okay, so I've got 4 more things for the the tier 1 items that I'll go through relatively quickly, and I think stop the screen sharing after that so that we can make it have a more interactive discussion if we have the if we want to start having that interactive nature. So the next item is updates, and right now this means FreeBSD update. And for tier 1, we say that we will provide binary updates and source patches for security advisories and erratas. I think we don't do this for ARM64 today, but we've prototyped it, and the infrastructure all works just fine. So I think there's no trouble at all guaranteeing that as of FreeBSD 13 we'll provide FreeBSD update support. Our long-term goal is, of course, to migrate to package base and perform updates via updated base packages. But in the interim, before that's released, FreeBSD update will support ARM64. Mitchell has prototyped it already, and there's a couple of minor issues that came out of that, some bug fixes and things that needed to happen, but there's no real significant effort for that. Now, there's one caveat in the ARM64 world, that FreeBSD update is kind of inherently not a good fit for systems that use SD cards, like a root on SD card. The slow access for root on SD doesn't really work particularly well with FreeBSD update. But I think it's not a blocker for us providing updates for the architecture, and server class hardware updates will work the same way they do on x86. There's been some discussion about whether we should prevent FreeBSD update from running on embedded platforms, and I think that's probably not really worth addressing. It's just something that we'll have to note as a caveat and suggest that people be aware of that issue. So we have some userland and kernel ABI stability requirements. I'm not going to talk through them, but effectively we have, for tier 2 or tier 3 architectures, we've used the fact that we don't provide ABI guarantees to be able to make more significant changes from one major release to another, or perhaps even within a minor release. So I think the kind of most extreme example of this was switching 32-bit PowerPC from 32 to 64-bit time T. So originally PowerPC 32 had a 32-bit time T, and we basically switched it over, and there was no backwards compatibility. It was just your old binaries aren't compatible with the new system. At the time that once we make ARM64 tier 1, we'll no longer have the ability to make those kinds of changes within or between releases. We guarantee that we'll provide backwards compatibility. And I think this is probably another thing that is not we don't do it today for ARM64. We have we reserve the right, I suppose, to make a change if we need to. But in practice, we haven't really had any issues recently of any different nature than we have on x86. So both ABI, our kernel, and userland ABI stability guarantees. Andy, anything else you wanted to comment on there?
I can't think of any time we've actually broken the ABI off the top of my head. The last one, the only one I can think of is prior to our first release, I removed sbreak and break.
Right.
And that was explicitly before the release, so that we didn't have the API guarantees then.
Yeah. So then finally, the last two items as far as tier 1 guarantees, some items around the development and the ecosystem. And I think I'm just going to very briefly go through these, but these are good sort of just starting off points for further discussion. So I'll stop the screen sharing in just a moment so that we can switch to a more interactive format. But basically what we're saying for tier 1 architectures is that if a feature gets added that is not something inherently specific to that to a platform, it should be implemented on all tier 1 architectures. And I think this is, I suppose, you know, there's a sort of a continuum of features that this may or may not apply. This may apply more or less to. So an example of something where there might be some debate is something like Bhyve, which you know, there's work in progress to add Bhyve virtualization support, hypervisor support for ARM64. It's not in the tree today, and I think, you know, the fundamentally this is something that we'd be willing to say if this was implemented for only one architecture, we'd be willing to allow that sort of thing. But I think the point in the tier list is really more around, you know, someone updating a subsystem to improve some sort of performance or something like that, and basically whether or not the other architectures need to be included as part of an overall plan for that kind of work. And then finally, just kind of the overall ecosystem. The architecture should be documented in the FreeBSD handbook. It should have active users and developers, and hardware should be available for developers to do experimentation, development, ports work, etc. So I'm going to stop the screen sharing now, and we can carry on the discussion from here. Let's see, there we go. So Mark, Mitchell, either Andy, any other comments on those last points?
Well, with respect to just features in general, I know, at least personally, for the past year or so, I've been trying to implement machine-dependent features specifically on ARM64 when that makes sense. The most recent example being the non-transparent superpage stuff that was initially developed by Caustic for AMD64, and then I spent a bit of time making sure that it works on ARM64 as well. So I do find that with the availability of ARM64 development systems having gone up over the past couple of years, it's actually pretty easy to support ARM64 kernel development. And actually, I have a collection of little boards, and then I also use Graviton to do sort of larger scale development. So it might be nice to enumerate some of the features in FreeBSD that, like Bhyve, haven't actually been adopted all that well in ARM64 yet, or rather haven't been made to work. Another one I can think of is dtrace, which is, I think, basically functional, but there's definitely a bunch of gaps in there that I would like to have remedied one way or another sooner rather than later. There's a number of VM optimizations, some specific to NUMA and some just generally that also makes sense to port to ARM64. But yeah, I was wondering what other ones we should be thinking about.
Yeah, I had some more slides that I think were not really necessary to get to, but Bhyve and dtrace were the two that I already had identified. I'm not aware of anything else offhand that's kind of top of mind. Mitchell, anything else that you oh, I guess performance profiling, HWPMC, you know, that work is definitely something that is not at parity at the moment.
There's some other small things. Oh, go ahead, Mitchell. You go first.
I was just gonna say I haven't given it much attention, but I think it needs some, just from the basic testing. And yeah.
The one I was going to list is already done, which is using the newer PCI Bridge driver instead of the older one for resource management stuff. But like early AP startup is another one. So there's little things like that that the language of that particular bullet point in tiers is a bit dated, and you may need to think. I think Bhyve is a good example of.
Yeah.
You really want to hold up a feature when it's not on XYZ architectures, and I don't know if that is quite the intent, but things like I'll give it like ones I'm thinking of, early AP startup or the PCI Bridge driver. You have to make some machine independent changes and then some platform specific changes. And I think one of the tensions I've had when talking with other developers is, do we require a developer making a machine independent change to have to go change all the platforms? Or is at some point, do people who specialize in that platform have to share part of the workload? And what is the trade-off there? And I don't know if we have, that's a gray area. And I don't even know that we can really black and white define what exactly that looks like. But I think that is some of the tension from moving what is an effect to only ever having one tier one architecture to having more than one. Because that's when you actually have to think about that problem and what does that look like. When you only have one, then yeah, you do the machine dependent part of the one. But anytime when we finally go from more than one to two, I think that's the tension of trying to discuss how that evolves and what that looks like.
Yeah, and I mean, I think the tier definitions aren't intended to be a sort of legal document, right? Or something that we use to litigate whether something is or isn't tier one to very intense degree. It's intended to be kind of a framework and shared understanding about what it means. And I would absolutely agree that I think the goal is for us to find a middle ground between while I implemented some machine independent hooks and throw the work over the wall, and now someone else has to get other architectures to build again, versus you can't commit that until everything is done for all architectures. I think there's a middle ground between the people who are interested in supporting a platform will contribute actively to the development of a new feature that affects multiple platforms.
And I know Warner, he's posted a link. Hopefully we can drop it maybe in the Slack and IRC as well. I know he's been trying to wrestle with some of that because a lot of the current overhaul, kind of the tiering language you did like the last year or two, was trying to codify what we promise to users as opposed to what we obligate developers a little bit. And it's I think we're a little more clear on what we promise to users perhaps, but a little less clear on what we obligate developers to do, and specifically in that question. And I think Warner is trying to help resolve that. So,
yeah. And one of the challenges I think we've really had about providing or articulating expectations of the developer community is it's been very difficult to expect or demand that developers contribute something when reasonably priced developer platforms weren't really available, right? I think in the past, we had really high-end server platforms, and we had 1 gigabyte maximum embedded boards, hobbyist boards, and things, but nothing in the middle that someone, say, developing, maintaining a port could reasonably expected to have to do their own development. And I think that's being solved both through a broader availability of hardware that is reasonably priced but sufficiently capable. As well as cloud resources and resources that the project can provide to developers. So for things like porters who need access to an ARM64 machine to do their development work, I expect that in short order we will have more than enough resources in the FreeBSD cluster for developers to have reference machines and things like that available.
Oh, and we have a question. Where did it come? I guess it came over YouTube. Oh, from Ann gave me. It's a question from YouTube that someone asked about big little support for ARM64. And I guess apparently eventually for AMD64, but we're not talking about x86 in this discussion group. So we'll restrict it to just ARM. Does someone want to talk about that on Big Little and FreeBSD in particular? I know nothing.
It depends what exactly they're wanting to know about is because we run already on Big Little CPU systems. We don't necessarily take into account the performance of any CPU in scheduling decisions though. And we don't really, and don't support some of the other work is to say turning off CPUs, which we don't support at the moment either. Or even just putting them into a super low power mode and turning off scheduling to them. So we do run on Big Little, but not as efficiently as we could.
Okay, I think that probably covers it in terms of answering the question, not in terms of the work.
Our support for ARM64 scheduling, like even in sort of homogeneous systems, is pretty lacking. Like the ULE scheduler doesn't know anything about the CPU and cache topologies, so it actually doesn't make particularly well-informed scheduling decisions today. On some platforms, obviously, that doesn't really matter so much. And interestingly, Graviton is apparently architected to try and minimize the creation of a complex topology. It's kind of a flat space where there's no NUMA. Each core has private caches, and they all share a cache as well. So there isn't much. There isn't a sort of multi-level hierarchy there. But on other server platforms, I don't actually know, but Ampere and Cavium probably does matter a little bit more.
I mean, it will be interesting to see how Intel implement their Big Little design and see if that's compatible or if the whole world needs re-architecting for two different scheduler systems.
So schedule-wise, you're actually at the end of our slot. We're supposed to have a break. So why don't we at least give anybody a last chance to throw in any questions they want to throw in? Otherwise, the next minute or so, I will kick into a break. I'm going to check YouTube right.
I don't see any other questions on the YouTube. Maybe over here on IRC. No, I don't see any other questions.
Okay. Well, thank you all for participating in our first panel of this type. So we'll go into a 10-minute break for now. And then when we come back, we'll have one more discussion topic. Peter Graham and myself will be hosting a discussion on Bhyve. And that will be our last session for today. So this is your last break. We'll see you in a few minutes. Okay, let's see. Hello, Peter.
Hello.
So this is our last session for today, for our first day of this Dev Summit, and we're going to talk about Bhyve. Neither Peter nor I have any pre-prepared slides like Ed, so we're just going to have more of a discussion, really led by audience questions and so forth. I did want to start off a little bit. Just when I talk to lots of, or hear from various folks using FreeBSD, two of the big things that come up over the past several years in terms of big features in FreeBSD, one is ZFS and the other one is Bhyve. And I know Bhyve got started by work that Peter and Neil did several years ago. And then Peter had a little brief hiatus where he was off working at another place, but he's now come back to us. He's rejoined and been active. So would you like to talk a little about that, Peter? Coming back, being active in Bhyve again?
Oh yeah, so I was able to resurrect my commit bit earlier this year. I think my focus right now is just trying to clear out the backlog and reviews, and also bugs. Every time I want to start on something new, people keep filing more bugs. So we got to get them to stop doing that. Probably one of the things I've been looking at recently is just graphics. So both pass-through, the different types of pass-through that can be done, and also some work on VNC. Basically, Bhyve started out as really a server class hypervisor, but increasingly it's used a lot for just desktop use. So we're just trying to make a better experience for users there. John, do you want to talk about the config work that you've been doing?
So I will say, like Peter, most of my time, the time that I can spend on Bhyve is trying to deal with, there are a lot of folks submitting patches and trying to help review things and get stuff in. So most of my Bhyve time is spent on that, but I do get to spend some time doing a little bit of work on Bhyve. And the current patch that I've been working on for several months, and I really need to get it merged in the tree at some point soon, because it's getting painful to keep rebasing, is kind of reworking some of the internals of how we store configuration information in Bhyve. I think I've seen the same failed bug fix for trying to fix memory leaks inside of string parsing in some of the device models, because of the way we currently do lots of string passing around. So some of what I've tried to change is to eliminate lots of string parsing in the backend device models, do it in one place, mostly in one place, and instead allow devices to kind of have key value kind of lists of configuration variables, and also makes it a little easier to extend in the future. So there is a review for that, and I know some folks have looked at it, and I probably have some more tidying. I think I have another open question or two from you that I still need to resolve, but hopefully I can get that landed, let's say, soonish. I don't know if I can promise when soonish is, but I would like to get that chunk of work in the tree. It's still it's a step towards having, for example, a nicer config file. I have kind of a very simple, basic config file you can use with this system, but there's definitely room for someone to write, for example, a UCL format parser that would give a nice config file format that people can use without having enormously long command lines. And also, as we move more folks using EFI booting instead of Bhyve load, being able to have a nice simple command line to run Bhyve without wrapper scripts and so forth in the same way. But I think now what we're really interested in is folks who might have questions for us. What are some things that they're interested in Bhyve? What are some things that they would, I'm sure people like to see lots of things, lots of new features that they would like to have. But what are some topics that folks are interested in? Let's see if I can see anything. One is saying things on IRC that have nothing to do with Bhyve. But I do know one thing that is a chunk of work that some folks are interested in. Well, we did merge a big bunch of changes from folks at UPB to add an initial framework for doing suspend and resume support. And I know they have a student who's continuing to do some work to refine that further to get us to a better file format that is not as tied to Bhyve's internal ABI, but more flexible to allow us to deal with evolving Bhyve implementations in the future. And I know one of those students is working on that. And there's also a pile of reviews I need to get to that are various bug fixes even to the current work. But that is in the tree in 13. It's still kind of experimental, so it's not on by default, in part because the config file, or not the config file, but the file format for save and a dump is not robust enough to really be stable across changes. But that's in the tree, and I know they're continuing to work on that. Another big chunk of work I know that is outstanding, and there's now been a review that's landed. I know you've looked at it a little bit, Peter, is ARM64 support in particular for Bhyve. I know some folks I work with at Cambridge. Andrew was just on our last roundtable for ARM64. He's worked a bit with like a fork of those patches, I think. And the folks at UPB have worked continuing with those patches and continuing to refine them, which I think is the current patch set that's been posted. So I know there's a lot of interest in that. I think it's going to take some time to figure out how we integrate that cleanly and kind of tear apart what the kind of x86 assumptions in Bhyve versus the ARM bits of the world. Oh, you're still muted, Peter.
Sean has a question on any updates to the live migration work, which I guess was partially answered with the save and restore.
Yeah, kind of. It is true that there is a follow-on work by one of the students. I'm not sure she's a student. She might actually be like a teacher now. I'm not quite sure of Elena's official status at UPB. She did some follow-on work that's not in the tree, which built on top of suspend and resume to add a live migration path that has VM changes and so that I know we talked a bit with Alan Cox and Mark Johnston to kind of refine kind of how that works and so forth. But it's still out of the tree. It's not currently in the tree. For me, I would like to kind of see some of the maturity happen to the save and restore work first, and then we can start adding some of the other things on top of it before we kind of add live migration, I think, in its current form. Let's see, we have another question. Interested if people having boot issues with EFI or CSM can get those documented and if they have reproducible cases. I'm not quite sure how to parse what that means. Although it is a good segue into another chunk of work. I know, Peter, you've been working with Rebecca on kind of a newer version of EDK2 for our EFI ROM, but I think the CSM bits are perhaps less functional than our current version of EDK2 that we're using. Is that an accurate statement? Oh.
With CSM, there's quite a lot of changes that are spread out through generic EDK2. So getting those into EDK2 could be problematic. Also, it's not actually working right now. I mean, it seems to be able to successfully deal with some BIOS calls, but not all calls. Debugging that is kind of tricky. I mean, my interest is how many people are still using CSM. Most guests have migrated to having EFI support these days. So, I mean, one possibility is that we just drop CSM.
I guess another route might be that we may keep CSM only with an older ROM. Like we could have a separate port for a CSM ROM that uses the older EDK2 perhaps.
That's right. So the issue with that is the older version of UEFI that does work with CSM is built with Python 2.
Okay.
And there's actually a massive amount of Python in EDK2, so I don't think it's a simple matter of just migrating that existing Python code.
I gotcha. It seems like we could at least perhaps have the non-CSM ROM of the newer version. And I don't know if we already have a port for that, like what we would call, I don't know if it would be a develop port or something. That at least might allow some people to use. I mean, is there a benefit to using the newer EFI ROM for folks who are booting with EFI?
Not really. I mean, there's some additional features that have, popped up in EFI since the 2014 snapshot, but I mean, at the end of the day, it's a bootloader, and it's not really a component of the system that's supposed to be very feature rich. I mean, I think there's a lot of value in keeping track of upstream EDK2, and now that Beck's CRAN has actually merged the Bhyve parts, that's kind of automatic. So the main issue is just what's going to happen with CSM moving forward.
Okay. Have you looked? I know Scott Phillips, when he was at Intel, had some patches to allow us to have like a backing store for the NVRAM for a VM. I don't know if you had a chance to look at that. And I think that might have been tied to having, I don't know if that's tied to having a newer ROM or not.
No, but I think the newer ROM makes it a bit easier.
Okay.
Bex said that they would look at that.
Okay. All right. Someone's comment about CSM, it's not really a question. They claim that it's an anonymous person, so I don't know who they are, claims that CSM is useful for booting pre-existing images. So if people have existing disk images or snapshots that predated EFI when the time the image was built, I guess that might be true. But I suspect that is a tail that will continue to shrink over time.
Yeah, it's also quite limited in what it can boot. I mean, there's no support for graphics booting. It's serial console only.
Right.
Alan has a question about VirtIO,
Yes.
whether there's any interest in moving to a more modern version of VirtIO. So I don't believe this actually does give any more I/O performance. It just means that there's additional features that you may be able to get. For instance, I think in networking, the MTU is exposed where it isn't in the 0.95 spec. But also any new VirtIO additions seem to be done in the new one. They're not really doing ones that work with the old version that's supported in Bhyve. There is actually work in FreeBSD in the client to update VirtIO, which I guess is useful for other hypervisors. But yeah, Bhyve itself only supports 0.95 at the moment.
I do know some of my experience recently, not in a Bhyve context, but with things like simulators from ARM or dealing with other people building kind of software device models around FPGA CPUs, that the fact that our client is restricted to legacy tends to expose incompatibilities in other implementations, and that they really make it work for Linux. And when they do that, they're basically writing to like a 1.0 or a 1.1 model. And so lots of times you'll find that when you then try to ask this device model to work in legacy mode, it falls over and doesn't work quite correctly. So I do think there is value in FreeBSD to get our client moved forward. I know Brian D has worked on it some, but I don't know how. I feel like the last time his branch was updated was quite a while ago. And there is some of that. I know you mentioned the newer features. Linux can be a little forgiving with that, apparently. I know Alan, the specific thing that Alan worked on was that in trim support, which in theory you can only negotiate in like 1.0 or 1.1, but it turns out if you set the bits as if you're trying to negotiate in legacy, it still actually works. So even though Bhyve's device model is still a 0.95, we were still able to turn on trim support and have it work with both FreeBSD and Linux guests.
Yeah, and there's sort of from a hypervisor point of view, there's a compatibility issue where you probably don't want to come up with the latest version just in case somebody was running an older operating system that was expecting the older version. So then you have an issue of having to manually specify which version you want to expose, which is kind of exposing internal knowledge that you shouldn't really have to worry about.
Yeah, there was the SM BIOS tables are kind of similar, I think, in that there's a tension between, do you advertise something old so that you can support older guests, or do you advertise something new that lets you report newer fields? Which is, I guess, a similar side of the problem. Okay, and then someone asked about, it's not really a Bhyve question. Sean Webb asked about client support for 9PFS. So we did have a patch set to add, like it originally kind of came from IX, along with some other folks contributing to land 9PFS support in Bhyve itself, using, I guess it's VirtIO's model for a 9P pass-through file system. I do know some folks at Juniper have a 9PFS client for FreeBSD's kernel. Although anecdotally from talking with folks who've tried to use it, they've run into some interesting things, like it works if you do one mount, but if you do two mounts, it doesn't, because not everything is split up into per mount data, I guess. So I'm not aware of anyone who is using it in earnest. I believe Juniper does use their client against, not Bhyve, but against QEMU, perhaps with KVM. But I don't know how close the patches they posted are to what they use internally. And I don't know of anyone else who's using it in earnest. I do know this stuff is all public. I'm not aware. I think it's on a GitHub fork somewhere. I'm just not sure exactly which one.
Well, I might ask a question then. So one thing that could be useful for Bhyve is taking advantage of the CI that's in place for FreeBSD. It'd be kind of useful to boot a number of golden images of guests and see if they work okay. Would you have any idea if there's enough resources in the project to be able to handle that?
That might be an Ed question, who's turned his video on, so maybe he can answer that question. I'm going to punt to him.
Yeah, I turned my video on because I think it's a question that I might be able to offer some insight on. I think it is a great idea, and this is sort of specifically to CI test Bhyve itself, right? So making sure that we can boot old FreeBSD and old Linux and Windows and whatever else. I think it's probably mostly a Lee Wen question because he's the one who's kind of got a vision for how the CI system is going to progress. But I think fundamentally it's not there's not a lot of complexity in doing so, right? I mean, I think it's we have machine resources available. It probably isn't something that's particular. We probably want to be running tests like this on bare metal hosts, right? We probably don't really want to be going trying to do this inside of nested virtualization in the cloud, I would think, for the most part. I think it's a great idea. Do we have repositories of images available at all that we can use? Like, is there do we have some scripts and images and such that we can run today and produce the results, or do we have to develop that as well as the CI infrastructure to actually execute those?
Well, the simple thing would just be live CDs.
Mm-hmm.
You don't really have to do any work, and you just want to make sure that it boots. And beyond that, you could do additional work to try out various things. I mean, the step past that would be to do a full install and then a boot of a guest. But the further you get along that, just the more work it is. I'm sure you could do some simple things and get a lot of coverage without having to do a massive amount of work, I think.
Yeah, but I suppose we don't really have a list of either a list or a repository of such images at the moment, right? It's sort of But do we have some ad hoc tests that you've used or others have used in the past? Maybe we can start just by scripting and automating those, and then like if we had a shell script or whatever the case might be that we can run, and it goes through and is able to do that sort of on some existing images, I think we could definitely have a discussion with Lee Wen about how do we get this running on a regular basis inside our CI environment.
Mhm.
Do you know if there is a repository of live CDs out there that someone's already kind of curated, or are we just gonna? I mean, we can certainly just go and start finding them, but I suspect some of the interesting older ones maybe are not going to be so apparent or so obvious anymore.
But I also think they're not so important. I mean, the main
I guess that's true.
You want to run, the current Ubuntu desktop, a number of Ubuntu LTS releases.
Yeah.
Currently supported Windows, and as many FreeBSD as you think is important.
Mm-hmm. On a related note, I wonder if there's some useful VNC automation-driven VNC utilities, so that we can inject keystrokes or mouse clicks or whatever in response to actions that the guest performs.
I don't know anything about that at all. The whole area of GUI testing is a big mystery to me.
I mean, one of the interesting things is that this could actually be quite useful. Just if we can get some of that infrastructure in place, this will also be very useful for us for testing FreeBSD, like the FreeBSD installer and our ISO images and things like that. If we can build upon using Bhyve, if we build upon CI that can perform Bhyve tests, we can also then build installer tests that run through and select the options and make sure that all of that works and whatnot.
Somebody just mentioned, Sean Webman just mentioned Selenium is popular for UI testing.
Something to look at.
We just had another question. Is there any work on making Bhyve work in more nested virtualization situations? It would be great to run Docker on a Bhyve, however slowly in more places.
It's not really a question of Bhyve, right? That's more a question of bugs in the outer hypervisor not dealing with nested correctly.
I think so. So certainly in recent Linux, it works just fine. It took kind of a long way to get there. But I think as of the 5 onwards with Linux, it's quite okay. I don't really know.
I know the UPB folks, when they were doing testing, they had problems with certain Xeon systems. If they had the X2 APIC enabled in bare metal, then trying to run Bhyve nested did not work well. And that didn't appear to be a Bhyve problem. It appeared to be a Linux problem of some sort.
Yeah, there's been a number of bug reports on this. So another is that if the underlying hypervisor exposes APIC virtualization, the way that Bhyve uses that doesn't work. So that probably needs some more investigation. But I think in general, it's sort of okay these days. It's been okay on VMware for a very long time, but just KVM took a while to catch up.
There is kind of a related question, which I know my viewpoint, I think it's the same as yours, is do we want to support nested virt in Bhyve itself, or like in FreeBSD? And my view is that nested virt is very complicated, in particular because there's no, while there is some hardware acceleration for, at least I'm more familiar with x86 than what Andy mentioned for ARM at least, but on x86, while there's some hardware acceleration for like a shadow VM, like the virtual CPU state, there's no notion of hardware acceleration for dealing with nested page tables. And so that when you have to deal with the EPT of a guess, it gets really messy, and you're kind of like, you have to do it all by hand, I believe. And that seems very complicated and very hard to get right. And I'm very loath to kind of add that complexity to our system personally.
Mm-hmm. So I know of one person that's working on it part-time. So one of the issues with testing, and I guess it's just testing in general, is that there wasn't really a unit test framework in Bhyve. It was all sort of ad hoc. All the tests that were used were discarded, like most software projects. But just recently, there was a patch put up to add KVM unit test support for Bhyve. So I think that's a good step forward in getting testing, and that kind of test framework is what you really need for nested. And in fact, there's actually quite a large number of nested tests in the KVM unit test framework. So I think that, hopefully that could alleviate some of your concerns about testing. The test matrix itself is quite challenging, just because you're adding kind of another 2 dimensions. But I don't think it's a huge amount of code. Basically, it's very detailed. And, if you just kind of look at the history of KVM, it takes a long time to get right. But the nice thing about it is it's very easy to disable. You just don't expose it. If you think there's issues, make it an opt-in. And similar to KVM, just continue to work on it until it gets better.
Okay, that's fair enough. I'm excited for the KVM unit test just to even run for Bhyve in general. Like even just be able to run it bare metal on a host to test Bhyve as a top level hypervisor. I think those tests will be really useful for us. I've wanted those type of tests for Bhyve for a long time. I'm glad someone else is doing the work.
So is it, the irony is that we've actually found a bug in the KVM unit test suite by running these tests.
Outstanding.
There's another question. Do you have any plan to improve, I think it's pass-through significantly? Yeah. Yes. So it's a slow process. There's a couple of different things happening here. So one is just general improvements in pass-through. GPUs have some quite different constraints on how you have to deal with them compared to other pass-through devices like network or storage. One is bar size. So there's been some work on improving 64-bit bar size in Bhyve. I think another requirement is being able to support ROMs for graphics adapters so that they can initialize correctly. There was actually some of that in the VGA BIOS patch that was posted a while back, and that just has to be extracted. I think some people are looking at that. So that's kind of generic pass-through. If you have like a machine that just has a PCI graphics adapter, there's been some work posted for Intel GVT-D, which is pass-through of onboard graphics devices. That work was done by Beckhoff. That actually had some requirements on a kind of a cascading set of patches. One was the dynamic registration and deregistration of bars, which I wasn't real keen on, but Mark Johnson has submitted a patch which fixes a potential hole with EPT invalidation, which I think takes away any concerns about the unmap of PCI bars. So that patch can go in, which is one less thing in the way of getting the GVT-D patch in. Beckhoff actually also posted a patch for AMD APU pass-through, although that seems to not work so well with a lot of guest operating systems. I mean, another interesting thing with GPU pass-through is it's not, if you're looking at it for, say, playing games, it's really not that useful unless you have solid input support. So currently the only input support we really have is either direct pass-through of an XHCI controller, which is sort of good for latency reasons, but it means that you have to have an additional keyboard and mouse. So I think we need to do some work on either pass-through of USB devices or perhaps another alternate ways of getting input like EVDev, or even a custom input method. So yeah, I guess the short answer to that question is yes.
But it's a lot of work, and there are many steps to that, I guess, would be a way to say it.
Yep.
And I do know, I know you've looked at USB pass-through. I think one of the UPB students this fall was also looking at USB pass-through. I don't know what the status of their work is. And that USB pass-through would be interesting. There are other use cases, like one bizarre use case I had was having to run a Linux guest to program an FPGA board, and I did it by using USB pass-through actually on a Mac to a little Linux guest to pass through that one USB device. So things like that would also be interesting, even not in the context of GPUs and desktops.
Definitely. And I mean, one of the common things that people want for that is just to be able to pass through webcams into like proprietary Windows video conferencing software.
Right. And Mark notes on the Zoom chat that just for the record, the EPT patch that Peter mentioned did get committed today.
Yes, I saw that. So the very next step is we can get the deregistration patch in.
And as far as non-GPU PCI pass-through, my experience is, I know that there was a couple of bugs. Well, there's one other bug I know of people having problems passing, I think it's an XHCI controller into Linux, and it doesn't work the second time is one bug I'm aware of. But in general, I feel like that's gotten a little more robust over the past several years. Like we have the ability now to dynamically take a host device, attach it, pass it into a guest, and then if you want to attach it to the host, you can. And we do a better job of using FLIR and things to reset devices.
Yeah, I think vendors are better about supporting that. I think it was kind of notorious for onboard controllers to not have any support for that at all. Yes, or support that didn't work. I know of one particular card I worked with where you could do FLIR, and I used it, and I used it to test a particular driver or lower versions of FreeBSD from the FreeBSD host. And this particular card, when you FLIR'd it, it didn't reset the firmware, so you had to separately do an actual PCI reset after you restarted the guest, and then it would work fine because the FLIR did everything but reset the firmware, which in this case was not helpful. I guess I can bring up one other point that was raised earlier today, and that's using Bhyve for Docker.
Okay.
I mean, you really don't have to do anything. It kind of just works. But there's probably a lot that could be done to make it, a more seamless experience, kind of like Docker for Mac, where you don't really see what happens in the background. There's just a Linux VM that's fired up, and then they provide host file system access for development.
Yes, I guess some of that might depend. And I guess you could either use NFS or even 9PFS. Like none of that needs a FreeBSD guest changes. Just the bits that are in Bhyve already.
Mm-hmm. Yeah, there is the case where they start up a VM per Docker session. You try to get more isolation rather than just having a shared VM that multiple clients access. And one of the issues there is just startup time. So currently booting a Linux kernel on Bhyve is not particularly fast. But I think there's a number of things that could be done to speed that up. So, if you look at what QEMU or some of the Rust-based VMs have been doing, that's just to directly boot a Linux kernel out of initRD, which is not that complicated. But then also, we fork an exec IASL many times during boot, and there's really no need to do that. All the fixed size tables could just be written out directly. And then the most complicated part, which is compiling the DSDT, that could just be also kind of written directly. It's a bigger project, but just to write out bytecode and bypass the compiler.
And I guess Steve Wills on IRC was saying that he's actually already done a Docker driver that uses Bhyve. I'm not quite sure if it quite matches up to Docker on Mac as you were saying, but he says he has something. And he claims it's seamless. So I've at least put the link in our chat.
Mm-hmm.
And I've also tried to bug Steve to join the Zoom, but I don't know if he will, because he has been working with Juniper's non-PFS client to try to test it. He said he could mount a file system, he could read and write, but any buffered I/O did not work, which I'm not quite sure how read and write work, but not buffered I/O. Maybe he means like mmap, which is consistent with the other anecdotal evidence I've heard of other people who have tried it so far. So, and at least he's, I guess, taking a stab at it.
There's another question here about suggesting that we should work on SmartNIC and DPDK to be more cohesive to Bhyve. I'm not too sure what the question is asking there.
But maybe, I guess, so one thing is VF pass-through generally works fine, but maybe this is in the light of something we've talked about a few times in terms of like having a user network stack in Bhyve, the way QEMU has one, and then marrying that with something like DPDK or NetMap to kind of give something that's kind of like a VF, but using user space networking instead of kernel space networking. For Bhyve.
Yeah, I can imagine DPDK as a backend. Actually, if that works on FreeBSD as a host.
It should, I believe. At least on the
I'm not sure if how well DPDK works with a guest, given that it kind of relies on polled mode. Maybe that's something that we would need to test.
Yeah, I know that Luigi's student, Vincent, his last name I would butcher if I try to pronounce it, so I won't try. And it might even be Vincenzo, not Vincent. He's done several changes with using NetMap on the host with a veil switch. And he has an interface, I think it's called PTNet. I'm not sure if that's the host model or the guest driver, to do things with NetMap or DPDK-like things for networking into Bhyve. But that's also not using a user space stack. I think it's still working with like a tap interface in some way.
Mm-hmm.
But do you still have interest? I know several years ago we talked about user space network stack, maybe using libuinet or something like that, just to kind of, and I guess as part of another topic, which is being able to allow Bhyve to be run as a non-root user for certain use cases. That would seem to be one of the things, because that would get you away from requiring a tap device, which generally needs root.
Yeah, I have done a version of that. I just extracted the slurp stack out of SimH, actually. It has a Unix domain socket to the guest, which just passes Ethernet frames. So you just run it as a daemon. It kind of worked okay. I mean, I don't know. Probably what you really want to do is, well, I guess that's the first step, is you just have an external daemon. but it would be nice if that was actually integrated into Bhyve itself. And that would kind of require the FreeBSD user mode networking stack to be built as part of the base system.
Mm-hmm.
And that particular piece of software always seems to kind of lag FreeBSD by quite a ways.
I know Patrick, I believe, is on this call if he wants to raise his hand to talk about it.
I mean, to me, that seems like a useful thing in general, just for FreeBSD, and that the user mode networking stack is actually built at the same time. It's just a part of base.
Well, let me see. It is 12:30. I'm not actually sure how long we were supposed to go for this session. What does it say? I'm trying to look at our page. Well, it's 12:27. Well, Pacific time. It's a lot earlier for you, I believe, right?
Yeah.
Some ridiculous. Is it like 5:30 in the morning or something crazy?
6:30.
Oh, almost civilized. But I think if we don't have any more questions, we can probably be good for today. So thank you, Peter, for joining and for talking about Bhyve. Thank you for folks asking questions. And thank you for all our speakers for today, for doing our first ever virtual vendor summit and what this looks like and how we're trying to do this. I know I kind of had fun today. I think this worked pretty well. So we'll come back tomorrow at the same time, starting around 8:30 Pacific. We'll see you either on Zoom or on YouTube. So thanks, everyone. We'll see you tomorrow. Enjoy the rest of your day.